mencapai budaya kerja yang selamat dan sehat, berharmoni menjalankan kerja dengan suasana yang selesa, produk berkualiti dapat dihasilkan, itu tanggungjawab semua. Penglibatan dan kerjasama, majikan kerajaan dan pekerja, biarpun di bandar atau di desa, tidak ada bezanya. Penglibatan dan kerjasama, majikan kerajaan dan pekerja, biarpun di bandar atau di desa, tidak ada bezanya. Keselamatan dan kesihatan, itulah matlamat diidamkan untuk kesejahteraan kita semua. Majulah Malaysia, maju. Majulah Malaysia, maju. Majulah Malaysia, maju.
was in these Swiss mountains that the world was first introduced to the phrase the Fourth Industrial Revolution, and it's been a hot topic among academics, politicians, and business leaders ever since. But what exactly does it mean? The term Fourth Industrial Revolution was coined by the founder of the World Economic Forum, a former professor named Klaus Schwab. Schwab wrote a book with that title to describe an era marked by a technological revolution that is blurring the lines between the physical, digital, and biological spheres. Let's break that down. Technologies like artificial intelligence, autonomous vehicles, or the Internet of Things are becoming ingrained in our day-to-day lives and even our bodies. Think of voice-activated virtual assistants, Face ID recognition, or healthcare sensors. Schwab first presented his vision of the Fourth Industrial Revolution at the World Economic Forum's annual meeting here in Davos in 2016. But to understand the idea, we need to go much further back in history, to Industrial Revolution number 1. The first Industrial Revolution started in Great Britain around 1760 and spread to Europe and North America through the early 1800s. It was powered by a major invention, the steam engine. The result? New manufacturing processes, the creation of factories, and a booming textiles industry. From the late 1800s, the Second Industrial Revolution was marked by mass production and new industries like steel, oil, and electricity. The light bulb, telephone, and internal combustion engine were a few of the major inventions of this era. The Third Industrial Revolution, sometimes known as the Digital Revolution, occurred in the second half of the 20th century. In just a few decades, we saw the invention of the semiconductor, personal computer, and the internet. So what separates the Fourth Industrial Revolution from the Third? Experts say the main difference is that technology is merging more and more with humans' lives, and that technological change is happening faster than ever. Consider this. It took 75 years for 100 million users to adopt the telephone. Instagram signed up 100 million users in just 2 years, while Pokemon Go caught that amount in 1 month. 3D printing is just one example of fast-paced technology in the Fourth Industrial Revolution. The industry has gone from a business idea to big business, with 3D printer shipments expected to increase from just under 200,000 in 2015 to 2.4 million in 2020. Today, you can have a hip replacement from a 3D printed bone, or use a 3D printed bionic arm. Talk about blurring the line between humans and technology, right? This new era of technology is driving a lot of innovation. You can see in this chart the number of patents related to the Fourth Industrial Revolution for things like 3D printing or AI has been climbing up and up since early 2000. Organizations are embracing new technologies to make their businesses more efficient, similar to how they embraced the steam engine during the First Industrial Revolution. But some companies and governments are struggling to keep up with the fast pace of technological change. Research shows innovators, investors, and shareholders benefit the most from innovation. The risk is that the Fourth Industrial Revolution is making inequality, which is already a big issue, even worse. One study found billionaires have driven almost 80% of the 40 main breakthrough innovations over the last 40 years. That's a problem when the richest 1% of households already own nearly half of the world's wealth. Experts warn we are in a winner-takes-all economy, where high-skilled workers are rewarded with high pay and the rest of workers are left out. Studies confirm technologies like AI will eliminate some jobs and create demand for new skills that many workers don't have. Privacy concerns are another issue as the Fourth Industrial Revolution turns every company into a tech company. Industries from food to retail to banking are going digital, and they're collecting a lot more data about their customers along the way. Users are starting to worry that companies know too much about their private digital lives. The World Economic Forum says a majority of leaders don't have confidence their organizations are ready for the changes associated with the Fourth Industrial Revolution. With tech changing fast every day, it's time to catch up. Hey everyone, Elizabeth here in Davos, Switzerland. Be sure to check out our other CNBC Explains videos over here and leave us any other ideas in the comments section. See you later. It was in these Swiss mountains that the world was first introduced to the phrase the Fourth Industrial Revolution, and it's been a hot topic among academics, politicians, and business leaders ever since. But what exactly does it mean? The term Fourth Industrial Revolution was coined by the founder of the World Economic Forum, a former professor named Klaus Schwab. Schwab wrote a book with that title to describe an era marked by a technological revolution that is blurring the lines between the physical, digital, and biological spheres. Let's break that down. Technologies like artificial intelligence, autonomous vehicles, or the Internet of Things are becoming ingrained in our day-to-day lives and even our bodies. Think of voice-activated virtual assistants, Face ID recognition, or healthcare sensors. Schwab first presented his vision of the Fourth Industrial Revolution at the World Economic
Baik. Kita boleh mula. Melayang serindik di atas permatang, merebah berkicau di hujung muara. Pemanis kata selamat datang, awal bismillah pembuka bicara. Yang berbahagia, Tuan Teknologis Profesional Nazruddin bin Ma'ali, Pengarah Bahagian Keselamatan Tapak Bina, merangkap pengurusi Strategi 6 Ogos serindik di atas permatang. Yang dihormati barisan ahli panel daripada Welmat, Universiti Malaysia Perlis dan Persatuan Teknologi Malaysia. Seterusnya para hadirin dan hadirat sekalian. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi semua. Alhamdulillah, bersyukur kita kehadrat Allah Subhanahu Wa Taala kerana dengan keizinannya dapat kita bersama-sama memeriahkan majlis kita pada pagi ini, iaitu webinar Teknologi Revolusi Industri 4.0 dan Teknologi Robotik. Pada kesempatan ini, majlis mengucapkan selamat datang dan amat mengalu-alukan kehadiran tuan-tuan ke majlis ini pada pagi ini. Bagi memberkati majlis kita yang penuh bermakna ini, marilah kita sama-sama menadah tangan, mengaminkan bacaan doa memohon keberkatan. Oleh itu, majlis dengan ini menjemput saudara Wan Hilmi Wan Hussein untuk memimpin bacaan doa. Majlis dengan segala hormatnya mempersilakan.
Assalamualaikum dan selamat pagi. Al-Fatihah. Bismillah. Bismillahirrahmanirrahim. Alhamdulillahillazi bi'ni'matihi tatimmus shalihat wassalatu wassalamu ala rasulina amin wa ala alihi wa sahbihi ajma'in. Allahumma yang munzila rahman wa ya fatihal barakat. Rasa kesyukuran penuh kehambaan kami persembahkan hanya layak kepadamu ya Allah dengan inayah dan rahmatmu. Jua dapat kami menyusun pertemuan dalam sesi webinar Teknologi Revolusi Industri 4.0 dan Teknologi Robotik pada hari ini. Kurniakanlah pertemuan kami ini dengan keberkatan dan limpahan rahmatmu agar kami memperoleh manfaat dan kebaikan daripadanya. Seterusnya terhindar daripada segala bentuk kemungkaran yang tidak engkau redai. Allahumma ya arhamar rahimin. Wahai Tuhan yang maha melimpah kerahmatannya, kami pohonkan agar webinar ini mampu menjadi wadah perjuangan kami dalam usaha mencapai objektif yang kami ingini. Selaras dengan usaha kami mencapai matlamat membangun modal insan dan membina negara dan bangsa. Tanamkanlah kesedaran dan keinsafan dalam diri kami, juga generasi selepas kami, agar bersama memikul tanggungjawab menjaga kebajikan dan kepentingan teknologi dalam JKKP, khususnya dalam usaha memetapat ke arah masyarakat yang mampu bersaing dan mendepani cabaran semasa. Ya Allah, Ya Rahman, Ya Rahim. Wassallallahu ala sayyidina Muhammad wa ala ahli wa sahbihi wa barik wa sallim. Walhamdulillahi rabbil alamin. Terima kasih.
Amin, amin, ya Rabbal Alamin. Majlis merakamkan setinggi-tinggi perhargaan kepada Encik Wan Hilmi Wan Hussein atas pimpinan bacaan doa itu tadi. Semoga majlis kita pada hari ini berjalan lancar dan dilimpahi berkat. Seterusnya, majlis dengan berbesar hati menjemput Tuan Teknologis Profesional Nazruddin bin Ali untuk menyampaikan ucapan perasmian. Dengan segala hormatnya dipersilakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera serta salam KKP. Tuan Pengadu Majlis, terima kasih banyak. Encik Ramli Hassan, Timbalan Pengurusi Strategi 6 OSMP 2025, Dr. Muhtar Zamimi Bidanjan, Setiausaha Strategi 6 OSMP 2025, dan Tuan Haji Nur Zanzuri bin Muhammad Nur lah pengurusi kita pada hari ini iaitu pengurusi Strategi 6 Program 2 OSMP 2025, dibantu oleh Encik Rufairul Azam bin Abdul Rahman, Timbalan Pengurusi Strategi 6 Program 2 OSMP 2025, Encik Muhammad Yunus bin Talib, Pengurusi Strategi 6 Program 1 OSMP 2025, Engineer Abdul Aziz bin Salim, pengarah JKP Kelantan, melengkap Timbalan Pengurusi Strategi 6 Program 1 OSMP 2025, Engineer Dr. Izarhan bin Abdullah, Pengurusi Strategi 6 Program 3 OSMP 2025, Encik Al-Fadhil bin Muhammad Saleh, Encik Ahmad Syarin bin Yusof, Encik Wan Helmi bin Wan Hussein, Tok Imam kita pada hari ini, Encik Muhammad Abdulwudin bin Muhammad Yusof, Puan Nur Azura binti Syari, Encik Uzaini bin Harun, serta para penceramah Mr. Edward Leong, Mr. Alan Hugh dan Mr. Alan Govan dari Walmart, yang berusaha Dr. Muhammad Sani bin Muhammad Hashim akan bersama kita dari Universiti Malaysia Perlis ataupun UNIMAP, Teknologis Louis Day dan Teknologis Aleppo dari Persatuan Teknologi Malaysia TEM, pihak penganjur, para serta tuan-tuan dan perempuan sekalian. Assalamualaikum warahmatullahi wabarakatuh sekali lagi. Terlebih dahulu syukur kepada Ilahi dengan limpah dan rahmatnya dapatlah kita bersama-sama dalam webinar Teknologi Revolusi Industri 4.0 dan Teknologi Robotik, anjuran JKKP, Jabatan Keselamatan dan Kesihatan Pekerjaan Malaysia, di bawah Jawatankuasa Program 2 Strategi 6 OSMP 2021-2025 dengan kerjasama Universiti Malaysia Perlis, Walmart dan Persatuan Teknologi Malaysia. Ucapan syabas dan tahniah saya ucapkan kepada tuan-tuan dan puan-puan yang telah menunjukkan komitmen yang tinggi untuk hadir ke seminar pada hari ini, dan jutaan syabas dan tahniah juga saya ucapkan kepada Jawatankuasa penganjur di atas usaha gigih dalam membuat persediaan rapi bagi memastikan seminar pada ini dapat dijalankan dengan sebaik mungkinlah. Tahniah diucapkan. Tuan-tuan dan puan-puan yang berhormat sekalian, seperti yang sedia maklum, Jabatan Keselamatan dan Kesihatan Pekerjaan ataupun JKKP merupakan agensi di bawah Kementerian Semua Manusia yang bertanggungjawab untuk mentadbir, mengurus dan menguasakan perundangan yang berkaitan dengan keselamatan dan kesihatan pekerjaan atau KKP di tempat kerja. Namun tugas untuk mentadbir, mengurus dan menguasakan perundangan ke atas 14.9 juta penunjuk yang bekerja ni bukanlah satu tugas yang mudah lah, tanpa ada kerjasama dan penglibatan daripada tuan-tuan dan puan-puan sekalian. Jadi tuan-tuan dan puan-puan yang hadir pada hari turut sama mempunyai tanggungjawab lah untuk memainkan peranan secara langsung dalam memastikan keselamatan, kesihatan dan kebajikan kepada para pekerja kita yang optimum di tempat kerja masing-masing. Tak kira lah sama ada di industri pertanian, penghilangan dan even di dalam industri sendiri ya. Sehubungan dengan ini, selaras dengan tema seminar hari ini yang merupakan aspek pencapaian, cabaran dan hala tuju KKP melalui penggunaan teknologi revolusi industri ataupun IR 4.0 dan teknologi robotik di era baru KKP di Malaysia ini. Di era baru ini banyak perubahan yang telah berlaku dalam aspek KKP di mana hazard-hazard baru, aktiviti-aktiviti ekonomi baru dan perubahan dalam piawaian kebajikan pekerja telah meningkat dan perlu ditangani dengan lebih berkesan. Dan kita jugalah Jabatan Keselamatan Kesihatan juga sekarang ini sedang membantu majikan dan pekerja bagi menghadapi wabak pandemik COVID-19 di tempat kerja dan meningkatkan kesiapsiagaan negara dalam rangka perundangan atau KKP yang lebih mampan dan pelaksanaan peran induk KKP 2021-2025 ya. Jadi tuan-tuan dan puan-puan yang berhormat sekalian, kita sedang diujilah dengan wabak pandemik COVID-19 di mana ia telah menjadi impak yang besar kepada komuniti dan juga aspek-aspek pekerjaan. Semua ini jabatan telah terlibat secara langsung dalam usaha menangani wabak ini di tempat kerja melalui kerjasama dengan MKN, KKM dan agensi-agensi kerjaan lain. So harapan jabatan adalah supaya ilmu yang kita pelajari ini, semua yang bertugas tempat kerja dapat digunakan bagi mengawal pemburuan jabatan ini sama ada tempat kerja maupun di dalam komuniti kita. Dan oleh itu jabatan juga telah menyediakan garis panduan SOP kepada majikan dan pekerja bagi mengawal jangkitan COVID-19 di kalangan pekerja, dan pada 12 Julai yang lalu jabatan juga telah mengeluarkan panduan pengudaraan kualiti udara dalaman, indoor air quality semasa pandemik COVID-19 ini. Baiklah tuan-tuan dan puan-puan yang dimuliakan sekalian, pada 22 Julai 2021 Timbalan Menteri Semua Manusia yang berhormat Dato' Awang bin Hashim telah membentangkan data kemalangan KKP tahun 2020. Kadar kemalangan di tempat kerja di seluruh negara telah menurun sebanyak 20%, manakala kadar kemalangan pula turut menurun 45% pada tahun lalu atau pada tahun 2020 berbanding tahun 2019 ya. So sebanyak 32,674 kes kemalangan pekerjaan direkodkan pada tahun lalu, dengan 312 daripadanya adalah kes yang melibatkan kematian. Ini menjadi kadar kemalangan pekerjaan di Malaysia pada tahun 2020 adalah 2.18 bagi setiap 1,000 pekerja, manakala kadar kematian pekerjaan pula telah berkurangan kepada 2.09 pada bagi setiap 100,000 pekerja. Walaupun kita nampak penurunan, namun pada tahun lepas dia merekodkan 300 kematian itu merupakan satu angka yang masih besar. Mana kalau kita congak lebih kurang satu hari berlakunya kemalangan maut di tempat pekerja lah, dan ini amat menyakitkan kita lah ya. So kadar kemalangan dan kematian ini lebih tinggi lah kalau kita bandingkan itu dan serantau. Banyak usaha dan program pencegahan perlu dilakukan sepanjang masa bagi terus menurunkan kadar kemalangan di masa hadapan lah. Ini termasuklah dengan usaha kita untuk pewartaan usaha baharu dan juga OSMP ataupun OS Master Plan ataupun Plan Induk KKP 2025 ini. Jadi tuan-tuan dan puan yang dimuliakan sekalian, untuk KKP Putrajaya Tapak Bina juga kami telah merancang beberapa penambahbaikan lah dari segi perundangan, pendekatan dan pelaksanaan KKP. Antaranya adalah contohnya di Tapak Bina kita telah melaksanakan garis panduan keselamatan pekerjaan dalam kurungan pengurusan atau dinamakan OSHIM, Occupational Safety and Health in Construction Industry dalam bracket management lah, yang berteraskan prevention through design ataupun PTD, dan kita juga memperkenalkan prinsipal ataupun prinsip pencegahan am ataupun general principle of prevention, di mana salah satu daripada pendekatannya adalah pencegahan melalui teknologi lah. Selaras dengan apa yang kita telah sedang kita akan bincangkan pada hari ini. Dan juga selain daripada itu kita juga telah pun menerbitkan perintah khas lah. Perintah khas Ketua Pemeriksa kepada pengurus bagi penggunaan selamat kren menara, susu sementara dan juga kren bergerak ataupun kren. So kita juga banyak melibatkan libat urus lah dalam membangunkan OSMP ini dan juga dalam aktiviti harian kita. Termasuklah kita mengadakan top management engagement, kita juga melibatkan urus dengan persatuan, universiti dan sebagainya. Dan JKKP juga sekarang ni seperti semua maklum juga memproses permohonan, pendaftaran dan sebagainya di dalam talian yang kita kenal dengan My KKP lah ataupun SCAD system lah. Dan juga kita juga melibatkan dengan penggunaan teknologi drone dan juga body camera yang akan dipakai oleh pemeriksa semasa mereka menjalankan pemeriksaan, dan juga pelaporan pengamal KKP seperti SHO, Safety and Health Officer, dan juga OSC, OS Coordinator di dalam talian. Semua mereka boleh menggunakan dalam talian dalam mereka membuat pelaporan dan sebagainya lah Tujuan kita adalah untuk meningkatkan kecekapan melalui teknologi dan juga meningkatkan pematuhan KKP lah. So tuan-tuan dan puan-puan yang sekalian, jadi bagi memastikan kesinambungan pencapaian KKP yang terusan, JKP telah merangka strategi jangka masa panjang lah, dengan mewujudkan Plan Induk Keselamatan dan Kesihatan Pekerjaan 2021-2025 ini. Jadi Plan Induk ini telah dibangunkan dengan mengikut semua input lah dan cadangan daripada semua pihak yang berkepentingan. Ia berpaksikan kepada 5 tujuan utama dan dengan 7 strategi pelaksanaan. So ini salah satu daripada strategi, iaitu strategi 6, pencegahan kemalangan dan sebagainya melalui penggunaan teknologi. Jadi pelaksanaan Plan Induk KKP 2021 ini akan diterajui oleh semua, oleh industri, pemegang taruh, majlis negara bagi keselamatan dan kesihatan pekerjaan dan juga JKKP akan menjadi kita semualah akan menjadi satu penggerak utama lah bagi setiap pelaksanaan strategi pada hari ini lah. Kita lihat pada hari ini kita melibatkan dengan pihak universiti, kita lihatkan pengguna teknologi dan juga service provider dan juga persatuan TEM sendiri, persatuan teknologi sendiri. Jadi kita haraplah melalui OSHIM ini semua pihak yang berkepentingan akan terlibat sama dalam memastikan keselamatan dan kesihatan pekerjaan atau KKP ini lebih berkesan di tempat kerja, di universiti dan semua tempat lah. Jadi kerjasama dan juga penyelarasan antara agensi kerajaan dengan punca kuasa yang berbeza juga akan kita pertingkatkan dari semasa ke semasa. Jadi tuan-tuan dan puan-puan yang dimuliakan sekalian, dalam usaha kita merancang kehadapan pada era yang penuh cabaran ini, jabatan memerlukan sokongan dan dukungan dari pelbagai pihak lah. Pastinya dari pihak penyedia teknologi, universiti, persatuan, para pengamal KKP dan semua pihak lah. Jadi antara kita semualah adalah menyebutkan nadi dan tulang belakang pada pelaksanaan KKP yang cemerlang di tempat kerja, terutamanya dalam aspek pencegahan kemalangan melalui teknologi. Jadi jabatan merakamkan penghargaan yang tidak terhingga kepada semua sebagai anggota barisan KKP bagi memartabatkan dan memberikan KKP lah. Ada semualah ya. Maka dengan ini marilah kita sama-sama mendukung amanah negara dengan ikrar dan iltizam untuk meningkatkan pematuhan kepada penggunaan pelaksanaan usaha yang perlu untuk mengelakkan kemalangan akan berterusan lah ya. Ini termasuklah dengan mengutamakan penggunaan alat, kaedah kerja, mesin, perkakasan dan teknologi yang lebih selamat dan sihat. Saya juga menyeru rakan-rakan sebidang semua untuk mengamalkan sistem KKP yang mampan dari selarilah dengan tema World of Day kita yang merangkumi semua aspek KKP seperti pematuhan kepada perundangan, penggunaan infrastruktur yang berteknologi tinggi, sistem pengurusan sistematik, sokongan keupayaan transformasi digital, Internet of Things yang cekap dan pantas, kontrak dan pembelian yang selamat dan sihat, sistem kerja selamat dan banyak lagi lah. Ini adalah langkah-langkah asas bagi pembentukan budaya pencegahan di dalam KKP. Jadi sebelum saya mengakhiri ucapan saya, sekali lagi saya mengucapkan terima kasih dan tahniahlah kepada Jawatankuasa penganjur dan komitmen dan kesungguhan yang tunjukkan bagi menjayakan penganjuran seminar pada hari ini. Dan juga saya ucapkan kepada semua peserta yang hadir di atas komitmen dan kerjasama yang diberikan. Maka dengan lafaz Bismillahirrahmanirrahim, saya dengan ini merasmikan webinar Teknologi Revolusi Industri 4.0 dan Teknologi Robotik. Sekian, terima kasih.
Majlis mengucapkan ribuan terima kasih kepada Tuan Teknologis Nazruddin bin Ali pengerusi program kita pada hari ini. So berdasarkan ucapan beliau tadi, saya dapat simpulkan bahawa kita semua ni adalah pemegang taruh bagi Ocean P 2025 dan besarlah harapan agar kita dapat bersama-sama lah untuk kita dapat menurunkan lagi kadar kemalangan di tempat kerja melalui aplikasi teknologi. Okey, peringatan mesra kepada tuan-tuan hadirin kita pada hari ini. Pohon untuk mengisi borang kehadiran ada pautan di bahagian komen. So boleh isi Well, Mat, okey dah ready? Mr. Edward Leong, Alan Hugh dan Ilan Govan
Yep.
Okay.
Selamat pagi.
Bagi sesi pertama, majlis akan diserahkan kepada ahli panel daripada Wellmat dan akan menerangkan teknologi berkaitan kimpalan. Dengan segala hormatnya dipersilakan.
Okey. Terima kasih ya Tuan Pengerusi. Selamat pagi kepada semua. Very good morning. Dalam presentation kita hari ini, saya akan campur bahasa Melayu dengan bahasa English lah. But mainly should be in bahasa English because the presentation is in English. So bear in mind, we have about 1 hour to kill for 3 presentation. We have to go it quite fast. So, but if you have any questions, please do not hesitate to just chat on the chat group there. Just type it in there. I will go through it. If there's any question during our presentation, I'll definitely help to answer as much as I can. All right. Same again. My name is Edward Leong. We are from the Wellmark Group of Companies. Today, we're going to present about 3 topics. That would be the welding in the welding field. We're talking about welding simulators, how to train, how to get involved with the simulation in welding. Then we're going to talk about the robotic system with some IR 4.0 capabilities. And also we'll talk about some machine maintenance, calibration. How do we check the safety of the welding machine itself? All right, so I'll go through the presentation. Give me a second. Everyone can see my presentation right now? Ada nampak tak?
Okay, clear.
Boleh ya?
Ah,
Clear. Kadang-kadang teknologi main pasal lah. Okay, jalan dah. Alright. Once again, selamat pagi pada semua. On the first beginning of this presentation, I would like to have a introduction of our group of companies. Give me about 2-3 minutes to let you know what we are doing. So as discussed, we are talking about simulation, robotic system, and the IR 4.0 with safety and calibration in the welding field. So what is a Wellmart group of companies? So we consist about four group of companies here. So we have the Wellmart and Thermowell, whereby we are doing a lot of servicing and tendering processes with the training centers, engineering schools, college vocational and whatnot. So we're providing the train the trainers program for the teachers on what is going on within the industries and what are the machineries or technologies that the industries is using, so that the students are capable to understand, and even the teachers itself know what's going on within the industries. Then we have the ProWell, in short we call PWTC, not Putra World Trade Center, but ProWell Training Center. Okay, so ProWell Training Center is specialized in the welding field too, where they provide a welding certification training, especially on the WQT test. We call the welders qualification test, inspection services. After you do welding, we need to have inspection on the welding. So who are the person who are doing the inspection? So we call them the welding inspectors. When the inspectors have been inspected, then who going to take care of the welding inspector? We call the welding engineers. So they are going to reconfirm what the inspector has done. So basically, these are the processes that we have on the welding field. Accordingly to, if you can see here, we are using, because in Malaysia, we have a lot of standards. We have people investment from the US, from the Europe, from Japan, from Korea. So when each country comes to come to Malaysia and do investment or do jobs, they have their own standards. So we do have all kinds of standards. And basically, ISO is the standard that most people are using right now. So that is the most general standards that we use to certify welders. Then we have Metal Art Solutions. They're basically producing welding machines in Malaysia. So they specialize in all types of welding machines and equipments within Malaysia itself. As you can see later on the Excel Wellmart, you're presenting Mr. Alan Hugh. They're specializing in automation. So all kind of automation in the welding field, yeah. So handling robot welding, robot cutting, robot CNC cutting, and all that. He will talk about it, Mr. Alan Hugh, later on. Okay, as you can see, they are the range. Just a summary of it. You can see automation system, training certification, welding simulation system, accessory and consumables. So if you look at here, so the type of simulation that we have is not just welding simulator. We have a driving simulator, we have the welding simulator, and we have the painting simulator. So what are all these simulations? But today we only concentrate on welding simulator. For the others, if you have my email and have my contact, if you want, we can do a presentation for you on later on what are the other simulations that we have. All right, for welding machine itself, we have welding machine ranges from the smaller machine up to the high-tech machine. Usually, orang tanya lah, berapa harga? So kita lihatlah, harga yang termurah sekali tu dekat RM500. Yang mahal sekali dekat RM100,000 pun ada. So it depends on what kind of material you're welding. Okay, from carbon steel up to aluminium, titanium. So it depends. If you want technology with IR 4.0 welding machines, we also have. Later on, Alan Hugh will discuss a bit more on the IR 4.0, what are the machine capable of doing. Then we have this kind of automation. As you can see here, we have CNC, laser, column and boom, handling, welding robots, fully automated roboting system. So anything to do with welding, engineering stuff, we are the right people to have to come to us. We'll provide a good provide consultancy and project-based depending on where you are. If you're in Sabah, Sarawak, definitely we are very difficult to go over there. But within Semenanjung itself right now, we're able to travel. Okay. Then, okay, let's talk about welding simulator. Okay, we get to the important point. What is welding simulator? So as you can see, the simulation itself is basically have two different simulation. We have the AR technology and the VR technology. The AR technology is basically what we call augmented reality. And the virtual reality is VR, okay? So it's just a short form of both words. But what are the difference? You can see here, the difference between the virtual and the AR is that AR allows a user to experience the real world, which has been digitally augmented or upgraded, okay? Virtual reality, by contrast, eliminates user from the real world experience of animations. So basically, if you are immersed in the VR, you will not able to see whatever at the background. Everything is animated. Everything is animated. If you're, for example, your flight simulator itself, I think a lot of people know it's actually, basically it's VR, but they have a lot of actual knobs and switches for you to play with. So it's the combination of VR and AR on this on the simulator, on the flight simulator. But if you look at welding simulator later, when I'm talking to it, I'll let you see the difference between welding in VR and welding in AR. What are the difference? All right. So for AR, I think most of the young generation right now who are playing a lot of games, if you remember, there's one time people like to download the game called Pokemon. So basically, Pokemon is an AR. Okay, you can see the small miniature yang tu patung dalam di telefon, tetapi background everything is still nampak tu jalan, bangunan semua masih nampak. They just animated part of it only. So that is called augmented reality. So why people want to use simulator to train welders? You know, we are in the 21st century right now. You know, people are, especially the youngsters, they are more digitalized. You know, they like to play with digital things on their handphones. They like to do training on the playing video games, training, or looking at, even taking exams on the phone will be very happy for them, rather than going to classes or sit down and do paperwork. They want to do everything on the phone. Well, that's good for us. So simulators are able to do this. So what they want to do with the simulators, they want to attract and engage a new generation of skilled welders. But skilled workers right now in the market is getting less and less. So we don't have a lot of skilled workers in Malaysia itself. So how do we attract these people? Every youngsters who's coming out from the sekolah menengah, they want to go to where to belajar marketing lah, management lah, lawyer lah. You know, these are all theory stuff. But we need skilled workers to build up the nation. So that's a very important key, right? So we definitely know that we have a lot of foreigners in Malaysia, but slowly they're going away. Who's going to fill the gap? So we need to fill this gap by attracting younger generation. By using this kind of new technologies, we're able to attract this youngster to come to learn about skill education. So within the simulation itself, you're able to speed up training skills. Why? It's like recently the Olympic, 4 years once. How do they train for it? It's all muscle memory. They have to do it every day. If they can do it 24 hours a day, it'll be good for them. Same goes for skill training. Skill trainings is all about muscle memory, eye coordination, right? So the more you train, the better your handling will be. Okay. Then lastly, with the simulation itself is able to use cost control on the consumables. In the welding field, we have a lot of consumables. We have the metal. We talk about carbon steel, stainless steel, aluminium, titanium. These prices of materials are very expensive. Some of the schools are spending 50,000-60,000 a year just to buy materials. Imagine we can save some cost of this material. Okay, safety at workshop, definitely it will. With simulation, there's safety because the machine is only single phase. We are not looking at the dekat bengkel tu ada machine 3 phase lah, lepas tu benda-benda yang berat lah, besi lah, kalau terjatuh ke, potong ke, panas. So This will definitely have a safety issue within the training center itself. Save the environment. Well, saving the environment is that when you do simulation, when you have welding, there's a lot of smoke, there's a lot of heat. So smoke and heat also, it's not so good actually for the environment, right? So we are able to save how many by some percentage without using the actual. Just by training using simulation, we're able to save the environment. So these are some of the points that I want to talk about. Why schools or training centers or skill training facilities are going into simulation nowadays. So these are some of the general figures that we got. This is not done by me, actually. This is done by some organization who were able to get some data around the world. And these are the things that they come out with. If you compare traditional versus the simulation training, the most important point is the 68%. If you look at that, 68% reduction in lab cost and environment impact. As I said just now, we're talking about 60,000 a year to 50,000. Let's say 50,000 a year. You're buying material. You can save at least 25 to 30,000 ringgit just by using a simulator. Actually, the cost itself for this the material is enough to purchase the simulator already to cover the cost. You pay for itself, all right? Then 84% less accident. Definitely, they say, you know, you're not in the lab anymore. You're in the computer room, okay? But by all means, don't forget about it. Actual welding still need to be done. You cannot take away the actual. So if we can save 50% of the time on the simulator, and we can train them on 50% of the simulator, and another 50% on the actual welding, the saving of 50% is already there. So these are the some of the key points that I want to talk about. Why are people going to simulation? This is not just for welding. If you go into, let's say, driving simulator, how to drive a forklift, okay? You use simulation, same thing. It saves you cost. Because if it's a simulator, it's easy, it's a program. We can manipulate like 5 simulator or 6 simulator car forklift together and put it into cloud, whereby the trainers is able to train 5 to 10 forklift driver at the same time and monitoring them through the computer. All right, so these are some of the examples. So if you can see here, I give you some examples of what is in the market right now. We're using in the industries and also TV. Why I say industry? Companies such as Volkswagen, BMW, Peradua in Malaysia, they are going into this simulation to train their welders using simulator, but they prefer more to AR system, augmented reality. In the market right now, there are 2 AR producer programming for the simulation. We have the Sodamatic from Seabury, which is from Spain, and we have the Vertex Lincoln Electric. This Vertex Lincoln Electric is from the US. All right, so these are the mainly 2 AR technologies that's available in the market. And for the price wise, you know, guys, you can just Google it. You can see a lot of things when you Google it. You want to know more about this kind of machine, just go to YouTube. You just type the name here and you'll be able to see what the technologies is about. Then we have the virtual reality system. This is more on the VR. So VR is you're welding on the air. Okay, you just wear a goggle with the cermin mata kat dalam lah. Then you just do your welding lah. Okay, you do the training. So these are the 3. There are more, but a lot of the companies are doing virtual reality. But these are the top 3 that I'm showing you. They are the weldability from SIF, that is from UK, and then we have the WAVE members also from the UK. From France, members from France, and then virtual reality from Pronius is from Czechoslovakia, if I'm not mistaken, okay, from the Czech Republic. All right, feature of a simulation teaching. What are the features? Why are we going to simulation teaching? Simulation itself is a reproduction of a system or process purely virtually. So it's this VR system is actually a combination of VR and AR. All right, so the simulation itself, it's like actual welding, but minus smoke and heat. You're not able to see the smoke. You're not able to feel the heat of the welding, but you are able to see the welding bit. Later on, I'll give you some videos. I'll show you a video. You see how the technology works. All right. Then we have the simulation is able to record actual welding data through video analysis. Why this is important? It's like, recently we saw the Olympic. There are people training the athletes by using simulation, by using technology to see how far they can jump, the muscle memory, how their muscle connects to each other. There's a lot of, maybe just recently, if you saw the news the past couple of days during the Olympics, you see how they train the athletes. It's all about technology right now. It's all about technology. The traditional way of training, hardworking training, number of hours, sweat and blood all into it, it's still there. But they use the technology to analyze, why is your problem? What is the problem? Why can't you jump this far? If you want to jump how far, how do you do it? How should you do it? All right? What kind of clothes should you wear? What kind of shoes should you wear? These are all technology. So same thing here. For welding, traditionally, we are able to weld. The teacher will look at the weld and look at the piece. Oh, your welding is very good, or your welding is not good. That is traditional way. But through this simulation, we're able to record the video of the actual welding. Then when it's done, we can analyze the welding. Why the students are not able to weld properly? What is the problem? Is it the angle? Is it the height? Is it the speed? We can analyze, and all the students can look at the TV or look at the presentation all at once, rather than going to the workshop where it's small and one person is welding and 20 students at the back looking at the welding. It's going to be difficult for the teacher to explain. Okay. Lastly, is the simulation allows acceleration of learning processes. With simulator, if per se, the machine itself does not sleep, we can open the machine simulator for 24 hours in the computer lab. So the student can come in anytime to learn. If they weld and it's wrong, they can just press reset, they have a new plate. So it's like you're doing welding within an hour, you can do 10 welding sequence in 1 hour. But on the actual lab, you're going to prepare the plate, you're going to cut the plate, you're going to do the welding. It takes you maybe 2 plates per hour. So again, it's all about muscle memory, right? So the curriculum is important. So when you train the skilled workers, you need to know what they have been trained of. Are they, when they come out from the training program, are they able to be absorbed by the industries? So what are the industry needs? The industry have many type of curriculum. As you can see here, we have the International Program Welders, IWS. We have the AWS, where we have American Welding Society. They have their own training system for welding. Then we have the German media, DVS, that's from the European South, from Germany. Excuse me. Then we have CISO. CISO is from the Spanish working community. We have ASME, more for the construction side. And then the basically European ISO standard, that would be the most general and frequent use standard within the world. All right. So if you look at augmented reality, why is it more popular? Actually, I want to summarize and give you all and let you know. VR is the most, people like to use AR rather than VR when it comes to welding. Because why? You have the feeling of a real welding torch. You are holding a torch itself. You're not in the air using two clip. If you have seen the VR, you hold two pieces of like a play toy and you do it welding, but it's not actual torch. But using AR technology, they're able to do the feeling of the torch itself. And then when you do electrode welding, those who knows about welding, the electrode itself will be consumed. So your hand has to go down lower and lower and lower. Okay. And then VR itself also is actually based on real welding current and voltage. And then all kind of welding process is capable, is able to be done within the AR technologies. Things that you can see here, MMA, MIG, MAG, TIG. Those people who knows about the welding technology, they know what this is for. So all kind of process. So when the student are able to do all this, the industry able to absorb. They need this kind of training skill to be done for the skilled workers. Then AR helmet reflects the real surrounding. This is like what I said. They're using barcode. So when the helmet itself detects the barcode, only that barcode become the animated. So things around you, if you put the barcode on the table, you can able to see the table, you can able to see your mouse, your hand, everything is still there, except for the barcode will be animated to a carbon steel or a stainless steel or things that you want to see being done on the program itself. Then PVC coupons to simulate different, that's what I said just now, it's similar thing. We use PVC with the barcode on it, so that when the camera detects, it will be able to show you what the items are that you want to do with it. There are many more. Why? AR is able to do many type of coupons. You want to weld a chair, you want to weld a car, you want to weld a door panel, we can animate the door panel. Lepas tu, buka pintu tu, letak barcode dekat situ. When the camera detect kat tu kereta, then dia akan nampak mana dia kena welding. So the technology is very advanced. It's able to do it. Some more, right now, the technology itself for AR, this only for AR, not VR. AR can do robotic training. So for those who are interested in robotic training, you don't have to spend time, doing wasting a lot of material, because robot itself is just an arm. You need to be trained to know how to program the arm itself and how to do angle welding, where to move. Not even not just welding, handling. You need to program. How do you program it without hurting for the safety issue? So these are the things that you need. So the AR technology is able to do that. And then AR itself also has the capability of doing cloud-based. So right now, everybody is talking IR 4.0. Well, simulation itself is IR 4.0. So the teacher can be somewhere, can be in Perlis, he can teach student within Selangor. So it's not a problem because this IR technology, everything in cloud-based and real time. So to cut this short, again, I think my time is not that long. I've been taking a lot of time. You can see here, this is what it is, cloud-based. So for example, if you have machines in Sabah or Sarawak, you want to have a look at what they are doing, yes, no problem. Or within rural area, let's say some places. But definitely, you need at least an internet link. If you don't have internet, router, anything to link up to the cloud, we are not able to detect all this, all right? So last but not least, I will show you a short video about this technology before I come to a close, before I pass the time to Mr. Alan Hugh for the next presentation. All right. Okay, so this is my presentation. I'm open the floor to questions before Alan Hugh comes in for the next presentation. Give me a second, yeah? I'll ask Alan Hugh to come in.
Hello, good morning. Selamat pagi. Good morning, selamat pagi, Datuk, Datin, Doktor, Tuan dan Puan. Yes, good morning. So, I'm here to present the... So I'm here to present some introduction things regarding the robotics system. Okay, so first of all, you can see here what is an industrial robot. So an industrial robot is a robotic system that commonly used in a modern manufacturing. And these the items that we so-called industrial robots are these are automatic, programmables, and capable of movement on 3 or more axes of robots. And then one information to update based on the International Federations of Robotics 2020 reports. Currently in the whole world, we are having 1.64 million industrial robots that are operating worldwide. And then, as you can see in my presentation slide, the blue colors part actually is industrial robots who come with 6 axes. So, and this 6 axes is this number 1, number 2, joint number 3, joint number 4, joint number 5, and then joint number 6 is to turning the things to 360 degree. And then this is acting as an arm of a system. And then as for the computer memories and also a CPU, for this will be a controller. So this controller will be used to memorize all the job that you have set for the robots. And then the items that used to set the robots will be pendants. This one, I give a closer look. This is the pendants. And then usually nowadays, the robots pendants will be on touchscreen pendants that you can easily set the program and then give the instructions to the robots. Okay. You can just now the report. These reports shown that there is quite a numbers of robots are being operating worldwide, 1.64 million. Then you might ask that why these companies like to implement robotic system in their factory. So here are some of the reasons. There is a lot of reasons, but I'm summarizing some of the reasons that is commonly shared by all these companies. First one, productions and quality consistency. When you are involving some products that you need a very consistent on your products output or qualities, then a robot will be a good solution. The second one, to avoid dangerous tasks for human. I will show you more examples afterwards. And then the third one is reduce human dependency. When you come to some productions where you need to have, let's say, 4 processes to complete into one product, you need to have 4 humans to be in the same production in order to produce the product. But let's say one of it was having sick leave, so there will be a problem on your productions flow. So by implementing all this into a robot system, then it will help to reduce this kind of problems. And then, of course, the last one will be ready your business for the digital IR 4.0 future. Okay, so here I'd like to share some of these the usage of robots with you. Okay, the first one here is a aluminium casting factory. As you can see, aluminium casting, the melting point for aluminium will be 660 degrees Celsius. Imagine if one drop of the melted aluminium fall on a human body, it would create casualties. Let's say when we use it, replace it with robot, then all these things can be, this dangerous accident can be avoided. And then the second video will be on a continuous process. Imagine one of the workers are on sick leave. then your whole production will be jeopardized. But with robotic system implemented, then this problem can be solved easily. Next. The drilling process, which need very accurate on the products. You need a very accurate on the whole drilling. So by using robots with their very high repeatability, so it can help to reduce and consistent your quality, as well as a plasma cutting process that I would like to show in the next video. Okay. On other process, let's say to avoid dangerous to human, this is a process for painting treatment. We know that painting, the smell is not good for human. So this can help to avoid a dangerous for human. And then another one will be on reduce a dependency on human. Let's say like this pelletizing process, which if let's say we are not automated it into a robot system, if let's say you're using human to pelletize the product, it will be, you will need a lot of human involving. Of course, these examples are inclusive of a welding process where you need a very consistent quality, welding quality output. Okay, so in today's presentation, I will be concentrating on welding robots. So in order to be successful, implement a robotic system, these are some of the elements that commonly you have to consider. Of course, there are many other elements, but these, the element that I'm list down today, will be common items that usually need to be considered before you are implementing a robot. The first one, that is what are the welding machines or welding equipments that suit your process? Do I need to, what kind of welding machines I need to integrate with? And then do the system need to equip it with a torch cleaning station or not? The second one will be a robot positioner, real track or rotation. This one depends on how big is your workpiece. Okay, the next one, about the quality of your weldings, and because of the consistency of your child part before welding. So do I need to implement a touch sensor or even a laser sensor into my system or not? And then the automatic, this is a training for the, okay, the automatic welding training will be a training system, how you're going to train your manpowers to operate the things. And last one will be on the after sales service. These people who are integrating your system can provide you a fast after sales service support or not. And then one more thing that is very important in a successful robot welding system will be a suitable design of fixtures and jig. All this we will explain more details in the next slide. So this is talking about, this is the standard robotics package that we have mentioned just now. So, and then about the welding machines to be integrated, these are some of the very common welding machines that integrate with robotic system in Malaysia. First one is the MIG welding machines. This is a China brand welding machine who are coming with quite okay welding performance, but in a very reasonable price. The second one will be a Lodge. This is a German brand welding machines who are coming with an IR 4.0 ready system. So whenever you need to know that your welding performance on every days, like what are the amperes that you're using, and then how many workpiece that you have produced every day, and then how many gas I've been using. With the IR 4.0 Lodge Connect system from Lodge, you are able to help you to summarize out and also giving you a very clear picture on what you have did and where you have been doing daily. Beside this one, Phoneus will be a very famous brand for the candidates or for the company who are looking for a very good welding outcome. Then the last one will be on Canby. These are the four very common welding machines that I've been using in Malaysia. Beside this one, these are the torch cleaning station. What are torch cleaning station? It's able to perform a few things. That means in order to ensure your welding quality, so you need to ensure that the shooting gas that are coming out from your nozzle is consistent. So you need to clean your nozzle, and then you do control this wire length to performing a good weldings with a consistent arc length. You need to cut your wires to the standard length side, and in the same time also to prevent very much of the consumable usage, you need to have an anti-sputter spray to elong your nozzle lifespan. So here is a short video to show how a torch cleaning station perform. Here is to cleaning the nozzle, cutting the wire length, and then inserting the anti-sputter spray. So the next one will be on the, let's say when we are welding a big part that is contained of 6 meters of wood piece. So we know that a standard welding robot can have a length arm up to 1.4 meters. And then talking about a long arm robot will be only go up to 2 meter or 2.6 meter maximum. So it's impossible for you to weld a 6 meter wood part. Then a real track system will be good because you can slide your robot from left to right so that you can cover a very big part. When it comes to products that you need to weld up and down, and then without dismantle your parts, and then to prevent this distortion, a rotator will be a good choice for implementing into the system that you want to weld. The next one will be a turntable. These systems are commonly used in a manufacturer who are trying to keep a safety distance for their workers with the robots, so that you can see after you have implemented all your parts on the outside outside jig, then this ready part will turn into the robot welding distance, and then it will perform the welding, and then the already welded products can be uploaded and unloaded from the welding jig. The last one will be a 2-exit turntable. This is very good to welding something that is round a circle. And then of course there will be a lot of other system available as well. So it depends on the needs and wants of the customer, and together also the budget available for the customers. The next one that is very commonly affecting the quality of the welding product will be the welding jig and all fixtures. So a welding jig and fixtures, a simple one can cost simple maybe from this 5,000 ringgit Malaysia up to 100 or even 200,000. It depends on the accuracy, depends on how complicated is your welding parts, and then also that the quality requirement of your products. Here, again, another short video to show how this welding jig. Imagine a welding jig like this one who are running automatically with this air cylinder. All those I think might cost you nearly 200 ringgit Malaysia. Depends on the quality requirements and also the budget of customers. Another thing that you need to consider will be on the touch sensor. So here a short video to let you understand what is a touch sensor. So a touch sensor will be needed when you are welding a part that very inconsistent on your child part. It means your cutting might have some variance. We're not able to consistent providing a place for you to weld. So a touch sensor able to let the robots to go and feel, to touch where is your part. So then they can simulate the art simulation place and then go perform the welding. Please bear in mind that a robot is something like a blind object, that he cannot see your products. It can only feel. So you need a touch sensor to help him. It means you're taking his hand to the touch on the parts to let him know exactly where is your product. Then he will be able to weld it more consistently. But come to some points that you need to weld the products that is very complicated, and even a touch sensor will not able to give you the performance and all the welding quality you need. Then a laser tracker will be another options to help you to solve the problem. Now, let me share with you a laser tracker video. The red laser light will be the laser light to detect where is the parts that need to be welded. Of course, in order to do this and then come up with this kind of outcome, a lot of pre-welding process need to be done, such as a very detailed study on the products, the quality requirement, and then also the budget is available for the project, as well as how consistent is the parts. So all this after you have gone through, then only you're able to perform the outcome in as per the video show. So this is the in order to giving this company to successful implementing a robots. So another system that is very important will be on robot simulation training system. So as what Albert just now have been introducing as automatic learning simulator, so this can be also integrated together with real robots. So we are using these real robots using real pendants to simulate the things. The reason for using simulator on robotic system is to train the welders and then able to reduce the consumable spending, reduce the cost. So we can see through these things, you can what the 4 step you need to do is the first one, you need to create the practice according to your WPS welding procedure specification. And then after that, you need to use your pendant to do the settings. What are the points to weld, and then all this kind of thing. After this one, perform weldings. And then the last one, the simulation will able to come out the inspection and then also the analysis, what are the welding outcomes. These can also help you to reduce all the consumables using during the training. Okay, so I think that's all for what I have to introduce on this robotic system. So, and then I would like to pass the time to Mr. Adam Gowan on the next topic. Thank you very much.
Good morning, ladies and gentlemen. My name is Ilan Gowan. Today we're going to present about welding data calibration towards IR 4.0. When we talk about calibration, what are the major key elements that play the roles? So when we talk about calibration, the important thing is about specifications, machinery, and people. So when we talk about machinery, the machinery should have a specifications in order people to do the calibrations. Okay, so these are the key elements. That's why I put a three important points. There is a specification, machinery, people. So each and everything is interrelated. Bear with me, this one will be a bit bored because I know when we talk about calibration, the company will need to spend money. So if the company spend money, it's for the safety of the people only. So when we talk about safety, okay, this is the simple picture that I've picked up from the websites. You can see here, okay, the welding joint. Why I put the welding joint? As you can see, the welding joint is a very simple thing, but the overall big picture is it's a big pressure tank. If let's say a welder was not trained according to the specifications or the machine is not according to the specification, what will happen? When there's a pressure, this thing will burst. So that's why I say, so the calibration play the important role. Just imagine if the machine is not calibrated and the machine is used to weld. 1 second. First, let's say the welder is not weld trained to do the welding. So what will happen? The machine's not calibrated, the welder is not trained to weld. So what will happen? End of the day, this one will burst. So this one will have a major accidents. Okay, that's what I say. The calibration play very important roles in the industry in Malaysia. Okay, these are the common practice in Malaysia. As you can see, all the small shops, all I can tell you, almost 70% to 80% of shops or the workshops in Malaysia usually will not wear the safety precautions. This is the standard practice in Malaysia. And this is a small and medium industry practice. You can see some of the some of the safety gears that they wear. This is a small and medium industry, and a big industry. These are the big industry. This is the standard safety gear they should wear. They should wear in order you to weld. You must have a welding helmet, a safety apron, welding goggles, gloves, shoe. All this one is a standard. So in Malaysia, the third one is the correct checklist in order to become a good welders. Okay, so we go back to the key point, calibrations. Two fundamental understanding when we say calibration. First, the meaning of calibration. Meaning of methodological in calibration and world of measurement technology. Calibration, it is a documented comparison measurement calibrated against a reference or calibrator. Okay, calibrator usually we say as a master equipment. So when you want to measure a welding machine, you must have a master equipment to compare against the device that going to be calibrated. First, second thing, the person who going to calibrate also should be competent enough to handle the master equipment and the welding machine itself. So when we talk about calibrations, three things come in the pearl. Three things come to the picture. That is, a person should be competent enough, a person should be electrical or mechanical qualified person, so that they can able to read the equipments. Equipments is such as multimeter, clamp meter, RPM meter. These are the standards equipments they use to do the calibrations. Okay, these are the standards for calibrations. Factory calibration versus traceability. So what are the standards? It's called standard ISO 10725. So these are the things to compare when we do the calibration against the traceable standards. So for the British standards, it is a European standard IEC 60974 revision 14 2018 revised. These are the standard we use when we do the calibration for the welding machines. So in order to do the calibration, we need to validate, and we also need to check consistency of the testing during the calibrations. Okay, so why should we calibrate the machine? You may wonder why you should calibrate something, or what are the reasons for calibrating. In industry process, conditions are various for calibration. Example, the most and common reasons are accuracy of the equipments. So whenever you use any equipments, let's say it is welding machines or any motors or punching press machines or anything that runs, it has wear and tear. Something like our car. When we use our car for maybe about 100,000 kilometers, we need to change timing belt. We need to change a timing belt. We need to retune our engine. Why? Because as we know, it has a wear and tear. That's why we do a calibration. Industry machines also same things. So this is the main reason why we should do the calibration. Another aspect of these things is if you never do the calibration of the equipments, whatever product that we produce, it not meet the specifications. Okay, so we talk about evolution of a welding technology first. Okay, the first one is technology. This technology was created, I think, about 50 to 60 years ago. I think in now the generation of people would not seen this kind of a machine. This is a core moving machine. This welding technology machine is a very big, heavy, draw very high current, high output voltage, open circuit also very high. It's quite dangerous. It's quite dangerous in the sense of when you check the open circuit voltage, it is about 100 volt. So if it is, let's say you are using in the open air, or you using in the during the what you call in outside of open areas, you will have a very dangerous situation. That means since it's open circuit very high, it might short you or electrocute you. So with the new technology, but advantage of this old technology is, let's say this machine drop in the sea, or not say sea, in the river, or you do expose in the hot and sun, this machine can be used 20 to 30 years. Even the cover spoil also still can be used, but it's dangerous. But the new technology machine is light, heavy duty, portable, easy to carry around, built with a low open circuit voltage. So this is where the aspect of safety come to the picture. Like this, as you can see, the new technology is very small, portable, easy to carry around. But these are the machines, because as you can see, like in a mining area or in a shipyards, open circuit voltage play the very important role. Why? Because not only one machine, they'll be using about few hundred welding machines in the shipyards or in the mining area. So if your open circuit voltage is very high, this is where the electrocution will happen. So with a new technology, so the safety aspect become very high. With the old technology, risk factor become very high. So these are the difference. So these are some of the welding machines available in Malaysia and throughout the world. So we have a Lodge machine, we have Synex machines, we have a Lincoln machine, Miller machines. So these are only some of the top brands available in Malaysia and throughout the world. So apart from this, there's hundreds of brand now, because but nowadays everybody have a money, can just put their brand and import. But do they check anything? They don't know. Do they know anything about quality? No, nobody cares. Because as long as they put a brand, they put a label. Nowadays, like assume like they put it as a 500 model, they say 500. Is the machine actually 500 amps? Nobody knows, because nobody cares to check. This is where calibration come to the picture. Okay. Before we talk about calibration, we talk about welding hazard in a company. So as I say, if let's say nobody check the calibration or the machine's quality or do the proper maintenance of the machines, these are the things that might happen in the factory. These are the things that will happen in the factory: fire hazard, electric hazard, fumes, ventilations, gas, hot works, burn shocks, eye injuries, repeated trauma, hearing loss, prevalent cause of injuries, improper body positioning. These are the things will happen when you are using welding machines with not proper educations. That means you are not well trained to use the welding machines, because not only your eyes or the bodily injury will happen when you're using welding machine if you are not trained. That's why we say training and calibrations play the very vital role in welding. Okay, so now we talk about a calibration. These are when I talk about the master calibrator, these are the master calibrate that we use in our organization to calibrate all the welding machines available in the markets. So these are the 800 amps machines. We have up to 1000 amp calibrator. So these machines, usually what happen is we use 800 machine to calibrate 500 to 600 amp machines. We use 500 amp machines calibrator to calibrate 300 amps welding machines. So these are the ways, traditional way we do the calibration. As you can see, traditionally we need at least 2 to 3% to do the calibration. Another aspect of when we do the calibration is, let's say you are not comply with the IR 4.0, you need to stop the welding works in order to do the calibration. And it also what you call time consuming, because in order to do the calibration, at least one machine will take 30 minutes to 45 machines to check thoroughly. So if the machine is did not comply with the calibration standard, we need to push aside. We need to service. So as you can see in the picture, these are the two general pictures how the calibration is done. Usually, one person will check the master machine, the other one will check the calibrator to verify the output is same. That means the tolerance will be about plus minus only 5% is allowable. So these are I show you a video, a small video. These are the calibrator. These are the machines that you can see that this is how we calibrate. these are the bill meters, that is ammeter, voltmeter. So let's say we want to calibrate according to 200 mAh, we just select 200 amp, then we set the machine so 200 amp. So we see the output here, whether the ampere here and the ampere in the machine same, voltage here and here is the same. Okay, these are the standard methods how we do the calibrations. Okay, but with the new advanced welding machines, the calibration and the setting become very easy. The setting for the large machine is only like a key card, like a ATM card. You just swap. The supervisor will program. Let's say a welder, maybe a welder need to weld a 500 amp 37 volt. So he will key in the a welder this 500 amp 37 volt. So he just need to swap. These are the technology. So when he swap the machines, he cannot change any parameter in the large machines. So it's already preset. So the welder only can weld at the specified as per programmed in the card. So the why I say Industry 4.0 is with the large machines, with large machine Q connect, Q data, whenever the welder is welding, so all the records will be recorded in the cloud or in the large Q connect itself. The supervisor just need to sit in the office to see the record how the welder is doing the welding. Apart from that, the welder cannot change any parameter because it's already programmed, first thing. Second thing, let's say the work is finished. People also can have a traceability, because important thing do the calibration is traceability. Let's say a sample was welded. So anybody can know these are the amp, these are the voltage, and these are the welder that did the welding. So everything is traceable to the standards. Nobody can do any hanky-panky job during the welding, or whatever happened, we can traceable to the welder, and also we can traceable to the root cause. So apart from they connect to the handphone or data, we also able to connect with the handphone. That means, let's say the supervisor's on the move, and there's a welder doing welding in the production line. He also can see how the welder is doing. This one is connect via Wi-Fi, and it's everything is recorded in the phone and also in the cloud. Okay, online monitoring, smart productions. That means nobody can cheat. You know whether the welder is welding, because these are the digitalization area, and traceability and tracking is come to the picture. So with the Q data, you have a welding parameters such as a current, voltage, wire feed speed, gas flow rate. With the Q data recorder display while recording the welding data. So we also have a RFID clearly assign the welding process, the welder who performed that, additions such as job part, weld seam, everything is recorded. So it is either transferred via USB or via cloud. Okay, apart from the large welding machine, we also have a mechanized welding and a cobot welding. Mechanized welding is to prevent the what you call manual welding. That means you already program the track to weld according to the, but the disadvantage of a mechanized welding is you only can weld a straight line, either vertical up or vertical down, or straight lines only. Then we also have another, apart from, as LNU just now discussed regarding the robot welding, we have a cobot welding. Cobot welding comparable to robot welding. Cobot welding is let's say the cobot welding, for the robot you use a pendant, but for the cobot welding you just drag the welding point to the place that you're going to weld, and reprogram it, and it will weld according to the specified location that it has been programmed. So with the new technology, it's very easy to weld. That's why we call it automated welding. So these are some of the track weldings and robot welding that has been explained by LNU. So with this one, robot and human work hand in hand. Process and data are digitally accessible to everybody. So this is where maintenance and calibration come to the picture. So when we talk about calibration, so the important thing is accessible. So all the data is accessible to everybody that want to see how the welding work is done. So with the Internet of the Thing has arrived in the industry and digitalization is well advanced, we can have quality works with as a product and digital service on progress. Okay, these are the welding machines. As I explained earlier, there is a large machine, Elmatex. So this Elmatex machine, another advantage is it has what you call it has SD card. So whenever the welder is doing welding, it can have all the data inside the inside the SD cards. So after the complete the work, they can take it out the SD card and check what are the parameters that he used to weld, what are the gas usage, what are the voltage or ampere that he used. So apart from that, we also have a Binzel ERW gas management system. This advantage of Binzel gas management system, let's say normally we use about 20 liter per minute. With this ERW2 net, we can reduce about 50 to 60%. We need only about 5%, but the output remain the same and the quality also remain the same. So these are the advantage of the new technology. Then advantage of this one, all this data will be have in the system. It can be collected either via internet or via cloud. Okay, so when we talk about calibration, the important things we need to talk about maintenance. So maintenance. So when we talk about, yes.
Sorry, Mr. Langawan, you got 1 more minute.
Yes.
Okay.
Okay. So when this will be my last slide. Sorry, because it's a drag a bit. So when we talk about maintenance and calibrations, we talk about corrective breakdown maintenance, schedule maintenance, preventive maintenance. So the important thing is predictive maintenance towards IR 4.0. Predictive maintenance is something like pencegahan. So we use a special tools to gauge using sensor and camera, manufacturing, process control to feedback, process modeling and monitoring, compare actual versus predicted dynamic, use of time series analysis to understand the predictive maintenance, explore how machines use such as cameras and images to inform decisions whether need to calibrate or need to do maintenance on time. So these are the predictive maintenance towards IR 4.0. And finally, before I wrap it up, here are some of our presentation. Thank you very much for inviting us, Walmart Group of companies, to participate in the webinar. Before I end this presentation, do anyone have any questions? Please write down in the chat group and we will feedback to you, or we'll give you our emails. If we are unable to answer, we will feedback to you by email. Thank you very much.
Terima kasih kepada tim Walmart yang terdiri daripada Tuan Edward Leong, Alan Yu dan Ilan Govan atas perkongsian mengenai teknologi kimpalan dan robotik sebentar tadi. Mungkin kita ada satu soalan ni from one Mr. Airi Rizal Arshad regarding welding in construction being done in dangerous situation such as working at height, building edges, confined space, etc. So maybe Mr. Edward Leong.
Yes, sorry,
can
I'm
give
back.
a quick response to this.
What was the question again? I just came back and sit down. Sorry about that. Can you tell me the question again?
Mr. Airi Rizal regarding welding in construction.
Yes, yes.
Being done in a dangerous situation, working at height, confined space, building edges. Can Walmart share ideas or suggestion on how to incorporate robotic or automation welding in construction industry?
Definitely, Mr. Rizal. Mr. IZ Rizal. Thank you very much for your question. Automation in construction, it can be done, but as a consult, we have all the consultancy or even experience that have done. We have to look at what kind of welding you want to do. Is it on the beams, I-beams? Is it on welding on mesh wires or any other things, or trust? There's many other kinds of, it can be done. We have done some in Pahang and in JB, doing I-beams and C-channels for robotic weldings on constructions for factories. So do give me, later on we'll send our contact information here on the group and our email address, or you yourself, Mr. Rizal, do send us a WhatsApp. I'll put our number there and we can talk on that directly. And I can see the second question here is from about the welding simulator, is it, for TVET Institute? Yes, you're right, TS Engineer Abdul Razak, yeah, you're right. Currently, the simulation in a Malaysian market has been about 10 years old, okay? So there are quite a numbers of institute within Malaysia, the TVET Institute, who are using this simulation to train their students, ranging from 1 unit minimum at one school up to 10 units per school. So it's there. So I show you the few type of simulation. So there are many types here in Malaysia. So at the end of the day, they are looking for the AR technology. Why? Because the only technology AR has is because they are cloud-based, and we're able to change our Malaysian syllabus. So important when we want to train a student, a skilled student, we have to use our syllabus. We cannot use American syllabus. We cannot use German syllabus. We cannot use Spanish syllabus or even the Japanese. They're different from ours. Our Malaysian syllabus under JPK, Jabatan Pengurusan Kemahiran, it's different from other country. So the one that I show you, the Seaberry Sorameric from Spain, that is the only simulator right now in the market. They're able to change or update your syllabus into the system to train your students and teachers, right? So I hope I answer your questions about that. In the introducing IR 4.0, yes, we've been introduced to the students. Copy of the presentation, definitely not a problem. Please liaison with the Mr. Inche, the organizer, Tuan Pengurusi lah. He, I think, will pass all the presentation to him. Then you can get it from him. Even so, we are recording the video. We'll put it up in YouTube later on and send you the link so that you can have a look at the presentation for those who have missed it. And then the next question is, learning university doing the calibration process. Are they compulsory? Are the accreditation industry following? To tell you the truth, the industry is much more advanced than the training center or the universities per se in Malaysia. Because for simulation, definitely no. Simulation, schools are definitely having it. Industry, not yet. We talk about IR 4.0 welding calibration processes. Yes, industry is doing it because in order for them to get projects, they have to have specific welding procedures. They need to have welding qualification welders, qualified welders. They have to have a welding inspector. Then also all the machines need to be calibrated. That's what Mr. Elan has told. The industry is following. Not all. If you talk about mom-pop shop, those who are doing welding grills, buat pagar-pagar, buat apa, ketuk-ketuk cat kereta itu, sorry lah, mereka tak ikut lagi lah, because association atau our government punya practice tak lagi sampai situlah. So kalau kita lihat shipbuilding, oil and gas, manufacturing, beams, construction, yes. Macam construction kita tahu CIDB memang ada akta dia. Kena ada green card, kena ada apa ni bricklayer card lah, semua dia banyak jenis card ini. So they implement that. Calibration coming soon. I know they're going to implement because why? Calibration is important because that machine is going to do welding on a particular product. So if the product have a safety problem, it will involve killing or someone to the welders to the user. So it's not good. So I hope I answer most of the questions here. So if you do have more questions, I will send you my name, email address, and phone number. You can email or WhatsApp me later on. So once again, as a CEO of the group of companies, I would like to say thank you very much for the opportunity, for giving us this time to present to you all. Terima kasih banyak. Terima kasih.
Okay, thank you very much, Mr. Edward Leong, for the response and presentation.
Sama-sama.
Okay, kita boleh teruskan lagi ya. Kita ada lagi 2 sesi. Bagi
Boleh,
sesi kedua, majlis menjemput Dr. Muhammad Muhammad Hashim.
Okey, Assalamualaikum, selamat pagi. Terima kasih Tuan Pengerusi. Yang bahagia Teknologi TS Nazruddin, Encik Nur Zamzuri dan Encik Hilmi dan tuan-tuan puan-puan sekalian. So boleh dengar kan suara saya kan?
Boleh.
Boleh ya? Okey.
Boleh.
Ni presentation slide tak share lagi lah. Okey, saya Dr. Sani daripada Universiti Malaysia Perlis. Basically tadi pun Encik Allen ada yang daripada Walmart tu, yang second presenter tu ada terang sikit lah pasal industri robot kan. Tapi saya kat sini saya akan cuba untuk kongsi lah apa bukan setakat industrial robot yang robot arm tu, maybe in a very wide punya definition of robotics lah dalam industri ni. Okay. So saya akan share slide. Okay. So untuk pagi ni saya akan tajuk yang diberikan adalah overview of robotic application industry lah. Okay. Kalau tengok dekat saya punya front page ni, saya daripada Universiti Malaysia Perlis dan saya adalah associate untuk Center of Excellence, one of the COE in UNIMAP lah, under Mechanical Engineering punya program ataupun fakulti, iaitu COE Automotive and Motorsport Technology lah, MOTEC. So basically kita banyak deal dengan automotive industry macam Pro 2, Proton, Miros, so kita ada cooperation lah. Okay, dengan NCAP. Dan juga saya di bawah salah satu daripada researcher untuk ICSI Group, Intelligent Computing and System Informatics. Yang ni memang kita fokus pada robotics, basically lebih kepada mobile robotics lah. Okay. So untuk permulaan ni saya nak terima kasih dululah kepada JKKP sebab beri peluang saya untuk berkongsi pengalaman, kongsi pengetahuan apa yang saya ada tentang robotik sini lah. Okay. Basically sebelum kita start tu saya nak tunjuk dululah UNIMAP ni kat mana. Sebab UNIMAP selalu orang confuse dengan UMP. UNIMAP ni adalah Universiti Perlis yang terletak kat Perlis lah. Kadang-kadang orang ingat UMP tu adalah UNIMAP lah. Basically UMP adalah Universiti Malaysia Pahang. Ada dua universiti yang berbeza lah. Tapi basically UMP Unimap ni adalah di bawah MTON lah, Malaysian Technical University Network lah, MTON. So dia ada 4 universiti bawah MTON ni, Unimap, UMP, UTEM dan juga UTHM dekat Johor. UTEM dekat Melaka lah. Okay, so network ni ada 4 technical university. So basically sejarah dia, kenapa ada technical university ni, sebab kita nak serve local industry lah. Basically kalau Unimap ni Perlis, dia dekat local industry dia adalah Penang lah, industri elektronik dan industri elektronik lah basically yang banyak dekat Penang. So that's why penubuhan Unimap ni kalau tengok awal-awal tu dia punya fakulti adalah fakulti mikroelektronik, sistem elektronik, manufacturing, itu yang terawal lah, dan chemical lah yang terawal. So basically untuk mechanical kita start 2005. Penubuhan awal Unimap adalah 2001 lah. Okay, itu sebab sikit tentang Unimap. Lupa pula. Unimap ni kalau tengok dia ada 3 kampus utama basically. Satu ni terletak dekat Pauh ni lah, ini adalah main campus. Satu lagi dekat Padang Besar dan lagi satu adalah dekat Kanga. Okay, so yang main campus ni terletak betul-betul kat sepadan Kedah Perlis ni. Kalau lalu highway ni, calon Kuala Perlis highway ni, so akan jumpalah Unimap ni sebelah kanan. Okay, dan sini kita juga ada Lita Unimap untuk racing, dan Lita ni kita buat untuk go-kart lah basically. Dan dia siap tahun 2013 Lita ni. Dia seiring dengan penubuhan unit saya ni lah, yang COE automotif dan motorsport ni, dia seiring lah. Okay. Okay, sedikit tentang diri saya. Nama saya Muhammad Sani bin Hashim. So saya adalah senior lecturer dekat Mechanical Engineering Program. Saya join Unimap 2011, sekarang dah tahun ke-10 lah saya di Unimap. Okay, sebelum ni saya pernah bekerja dekat kilang pasir injection molding dekat Seri Kembangan. Dan selepas tu saya juga lepas daripada kilang tu saya masuk oil and gas consultant Cioda Malaysia lah. Okay, so basically banyak saya buat mechanical punya parts. Untuk oil and gas ni saya buat banyak static equipment macam tank, pressure vessel itulah yang untuk design static equipment. Okay, untuk pasir injection molding ni saya sebagai QA engineer lah, QA engineer untuk pasir injection molding. Dan di Universiti Malaysia Perlis, research interest saya terarah banyak kepada otomotif lah dan mobile robotics. So selalu saya akan tengok teknologi yang berkaitan dengan autonomous vehicles. Okay, autonomous vehicles. So ini adalah email saya kalau ada untuk apa-apalah untuk kontak. Okay, permulaan ni kita tengok dulu apa itu definition of robots. Kalau tengok ni sejarah robot ni mungkin bermula awal 1900 era 1900 lah. Okay, so perkataan robot basically dia datang daripada perkataan Czech iaitu robota, dan bermaksud drudgery ataupun slave labor ni. So maksud dia adalah buruh. Okay, so dia kerja buruh lah ni ya, kalau ikut dia punya definition robota ni lah. Tapi dalam tahun 1979 ada Robot Institute of America ni. So ada definisi baru untuk robots lah. Is a programmable multifunctional manipulator designed to move material parts to or specialized devices through various program motion for performing a variation of tasks lah. So basically dia definition ni lebih menyeluruh lah, termasuk dia punya autonomy robot tu sendiri, dia punya programming, dia punya otak dia, itulah yang lebih menyeluruh dia punya ni. So kalau kita tengok dekat sini, ini adalah gambaran awal robot lah yang dipentaskan saya rasa dalam tahun 1920-an kot. Ini. So ini adalah gambar awal dia. So basically ini adalah robot lah ni, 3 robot ni. So ini quite famous kat lah screenplay ni kalau berkaitan dengan robot lah. Okay. So dia berbeza lah, kalau tengok awal punya gambaran robot ni dia berbeza lah, dia more kepada macam humanoid kan, orang kan. So that's why dia guna robota ni, dia apa nama ni drudgery ni kan. So when did the robots come into existence? So basically the first modern industrial robot ni adalah Unimax ni. Okay, yang telah di-develop oleh Josh, ada dua orang lah, Josh Devol ni dengan Joe Engelbert ni. Joe Engelbert ni dia dipanggil father of robotics lah. Okay, so dia orang develop Unimax ni dalam tahun 50-an, dia buat 50-an 60-an lah. Okay, dan dia pun dah patentkan robot ni yang sebelah kanan ni lah, yang Unimax ni. So basically this is the first industrial robot lah, yang tahulah the existence of industrial robot. Okay. So dua orang partner ni, dia orang dah form satu company animation, dan dia orang telah marketkan dia orang punya manipulator lah. Okay, this is we call it manipulator. So apa relation dengan industri 4.0 dan juga saya letak SDG lah, Sustainable Development Goals. Okay, yang dibangunkan oleh UN tak salah tahun 2015 lah. Okay, so kalau tengok definition IR 4.0 ni, it refers to a new phase of industrial revolution that focus heavily on the interconnectivity, automation, machine learning and real-time data. So sebelum ni mungkin ada automation je, sekarang kita dah ke arah cloud based dan interconnectivity lah, communication apa semua tu. Mungkin connectivity antara machine human, okay, dan machine learning dan real time data ni, ini adalah cloud based lah ni. So mungkin kita dah dengar big data analysis, okay, big data. So big data come from the machine learning lah. Okay, kalau tengok yang pillars ni mungkin ada 9 pillars ada, tapi saya ambil yang 11 pillars lah. So kalau ikut autonomous robot is one of the pillars lah in the technological advancement ni. So kita ada autonomous robot dan kita ada big data and analytics also. So dua-dua ni memang interconnected lah. Okay, dua-dua ni. So untuk autonomous mungkin kita perlukan big data lah, real time data ni, dan untuk dia punya learning ataupun machine learning Okay. So kalau dalam SDG goal dia adalah untuk achieve better and more sustainable future for all lah. Okay. So basically dia ada 16, ada 16, 17 ni adalah maybe gabungan semua ni lah. So total up dia ada 17 SDG, dan saya nampak mungkin untuk robotics punya SDG mungkin SDG 9 lah, kita mungkin ke arah industry, innovation and infrastructure. Okay. Tapi SDG ni adalah dia punya keywords dia, mungkin dalam ni dia lebih details lah. Okay. So few facts on robotics industry. Tadi Encik Ellen pun ada sebut ada lebih kurang 1.6 bilion industrial robots dekat worldwide ni lah, ataupun mungkin kat industri ya. Tapi source yang saya dapat lagi satu adalah mungkin kita ada lebih kurang 12 million robotics unit. Saya rasa ini termasuk semua jenis robots lah, tak semestinya industrial robots. Ni tahun 2020, IMAC ni adalah salah satu market research punya company ya. Dia buat survey ya. So basically kalau kita tengok number of robotics sold in 2020 rose to about 550 Okay, 450 ribu lah. And between 20 and 22, 12% increase in shipment. Okay. Dan kalau kita tengok semua ni ada increment lah setiap satu fakta-fakta ni. So basically kalau kita tengok years to years memang penggunaan robot dalam industri ni memang meningkat. Okay. Dan it is expected that global spending on the military pun dah guna robotics will be around 16 billion in 2025. Dah tak lama lah kan. So kalau kita tengok pharmaceutical ataupun medical punya robots pun dah meningkat penggunaan dia. Dan kebanyakan robot ni digunakan dalam automotive industry lah. Dia share around 42% market share lah of the robots ni. Okay. So apa kepentingan penggunaan robot ni? So salah satu kita tahu dia boleh buat kerja lebih efisien lah dan lebih cepat daripada human. Kalau kena betul lah programming dia tu. Okay. So basically robot can never get sick. Okay. Tapi dia boleh shutdown lah. Ataupun dia boleh ni semua macam tadi Encik Ellen yang second tu pun dah kata robot pun perlu juga ada dia punya calibration, dia punya maintenance perlu ada. Okay. Dia bukannya boleh kerja terus lah sampai dia punya jangka hayat dia kan. Dia perlu ada maintenance juga. Okay. So they can work 24 hours, 24/7 dan dia akan beri satu output yang konsisten lah in term of quality. Okay. So kadang-kadang kalau repetition punya kerja pun human ni selalu buat mistake lah. So kalau kita guna robot tu human error tu kita boleh reduce lah dalam operasi yang repetitif ni yang berulang-ulang ni. Kan kadang-kadang kalau human ni dia cepat buat dah, dia cepat boring kan. So dia mungkin akan melakukan kesilapan sikit lah dalam kerja-kerja ni. Dan kalau kesilapan yang tak melibatkan safety tak apa lagi. Kalau melibatkan safety mungkin bahayalah. Okay. Okay. So kalau robot dia ada advantage, dia mesti ada limitation juga. Disadvantage dia ataupun limitation lah. So kalau sekarang ni kalau kita tengok robot sekarang dia not very creative or innovative lah. Tapi saya rasa ini dah ke arah banyak research, banyak company robot yang robotics punya company memang dah banyak buat research dan kemungkinan kita akan nampak ni inovatif ni lagi banyak lah ke masa hadapan. And it cannot think independently. Usually it depends on the operator of the robot. Okay. And also the setting tu. Dan independent ni pun also kalau kita tengok, kalau kita dah boleh kaitkan dengan AI, artificial intelligence, mungkin dia boleh buat a few decision lah. Depends on the situation tu. Dia tak boleh buat fully decision tapi dia boleh buat a few decision depends on the situation. Okay. So sama juga ni cannot make a complicated decision even though it has AI lah. Dia tak boleh lawan dengan otak manusia lah basically. So kalau saya, walaupun kita ada robot, maybe kita needs to monitor lah, to supervise juga robot tu. Okay. So cannot learn from the mistake. Robot cannot learn from the mistake. Okay. And it cannot adapt quickly to the changes of its surroundings lah. Okay. So macam tu tulis bawah ni, every success business must depends on the real people for disabilities. So basically walaupun kita ada robot tapi kita perlukan real people jugalah untuk monitor, untuk tengok robot tu supaya tak berlaku apa-apa casualties lah. Okay, dekat tempat kerja tu. So ini saya list a few of broad areas that often using the robots. Okay. So basically selalunya kalau kita tengok robot ni kita boleh guna dekat dangerous environment. Okay. and dia juga digunakan untuk entertainment and leisure lah. Okay, kita tengok satu persatu secara ringkas lah, saya takkan detail out semua ni. Okay, and also digunakan juga dekat space, underwater, medical and industrial. This is a few broad areas that I listed lah. Okay, maybe it has more, but I think this is the main punya broad areas lah, the areas for robotics lah. Okay, so kalau kita tengok dekat dangerous environment ni memang selalu kita guna robots lah. Macam dekat welding tadi pun maybe yang tempat yang very dangerous mungkin kita akan guna yang robot arms tu lah. Okay, welding robot tu. Okay, so basically kalau untuk dangerous area ni macam carry out the bomb disposal, so kita adalah robot-robot macam mobile robot ni, dia boleh dismantle atau dispose bom lah. Okay, kalau kita nak guna manusia tu mungkin bahaya lah, kerana manusia tu kalau meletup bahaya lah kan. So kita akan guna robot. Okay, dan mungkin untuk collection of data collection, mungkin daripada volcanoes, daripada hazardous punya tempat, contoh mungkin ada radioaktif, so kita boleh guna robot lah. Okay, untuk exploring lebih kurang macam collecting data juga, and guna untuk military and rescue. So kalau kita tengok, saya ada tunjuk gambar ni, a few gambar, memang banyak yang mobile robot lah kat sini. Okay, untuk exploring apa semua ni mobile robot lah. So macam industrial robot tu kita banyak gunakan industrial lah, dia nama pun industrial robot kan. So dia more kepada robot arm ataupun manipulator lah yang ni. Tapi kalau kita tengok combination of manipulator pun ada juga kat sini. Contoh yang ni kan, so kita ada mobile robot and so manipulator. Okay, manipulator ni kita boleh untuk grab something lah ataupun okay. Dan dia ada banyak ni, ada yang wheel dan ada yang legged lah, leg kan. So ini ada animal, okay. Dia untuk exploring juga and data collection juga yang ni. So kalau dangerous area lagi, maybe kita ada drone ni ataupun predator. So dia memang kadang-kadang dia untuk survey je kawasan yang berbahaya, mungkin waktu tengah perang ke apa, dia akan guna drone lah untuk survey dulu kawasan. So and also kalau tengok yang ni adalah robot yang untuk angkat askar. So boleh juga waktu perang kan, ini adalah digunakan robot oleh bomba lah. And okay, salah satu robot yang digunakan untuk angkat mangsa mungkin kebakaran ke apa, so yang susah equipment untuk masuk, bomba untuk masuk, so robot ni akan pergilah untuk selamatkan mangsa. Okay. Dan kalau untuk entertainment pula, banyakkan kalau kita tengok mungkin kalau kita tengok filem ke apa, dia adalah macam Wall-E ni, mungkin kita ada daripada Star Wars pun ada yang okay, tapi yang tu macam Terminator, so itu more kepada entertainment yang fiction lah, okay, fiction punya. So kalau yang betul-betul kita ada macam Aibo ni adalah robot anjing lah, okay. Dia untuk entertain ataupun untuk entertain manusia lah, okay. Dan kita juga ada yang untuk boleh carry, kalau ada disable punya person ke, dia boleh tolong bawa, okay. Mungkin kita panggil ini nursing robot. Dan yang ni adalah robot Toyota ni. Kalau tengok memang saya pernah tengok dekat Jepun ini, memang dia buat persembahan yang untuk musical lah, okay. They have a few, dia ada team lah, a few members of the team ni. Ini cuma 3 je. Dan yang famous adalah Asimo ni lah, daripada Honda, okay. Dan kalau kita tengok sekarang pun kita ada air robot untuk vacuum cleaner juga ni, robot untuk vacuum. So ini boleh bantu untuk buat daily task kita di rumah lah. Okay. So banyak sekarang robot yang digunakan kat rumah lah, banyak yang dah jadi automated robot tu lah. So kalau untuk space, kita selalu dengar yang NASA lah. NASA memang dia ada robot arm ni dekat dia punya space station, dan sekarang pun China pun dah makin maju dalam space teknologi ni. So China pun dah buat robot arm dia sendiri dekat dia punya space station. Okay. So basically robot arm ni dia gunakan untuk maintenance lah. Untuk maintenance, kalau ada parts yang datang nanti dia boleh dismantle part tu dan dia boleh masukkan lah. Dia boleh keluarkan dan masukkan balik part yang perlu diganti lah. Okay. Dan yang ni perlukan robot arm ni sebab yalah kat space susah lah kalau human nak buat benda-benda macam tu, dan parts pun mungkin besar yang datang tu untuk digantikan. Okay, lagi satu mungkin untuk space ada juga rovers ni. Rovers ni adalah mobile robot juga, digunakan untuk exploring selalunya dekat Mars lah sekarang ni. Okay, dan ada juga yang buat ala-ala macam humanoid ni sebagai astronaut lah. Okay, untuk bantu dekat space station. Okay. Untuk dalam underwater pula, bawah air ni, so selalu kita tak berapa banyak sangat. Okay, so selalunya untuk underwater ni selalu dia akan remotely control lah. Okay, dan dia kebanyakannya untuk exploring lah, dan dia mungkin ada robot arm juga untuk grab something. Okay, ni sama je dalam bentuk berlainan je lah. Okay, dan kebanyakan untuk exploring dan untuk inspection. Kalau tengok ni dia untuk inspection yang bawah ni untuk inspection. Okay. So banyak, kalau inspection ni banyak guna dekat oil and gas lah. Kalau kita nak tengok kualiti bawah laut tu kan, welding apa semua tu, after few years tu maybe dia nak tengok welding dia okey ke tak ke, ataupun mungkin ada apa-apa, dia akan guna underwater punya robot lah. Okay. So kalau underwater robot ni macam saya kata dia remotely control. Selalu kalau kita tengok, kalau dekat atas tanah ataupun dekat udara, kita senang nak transfer dia punya signal. Tapi dalam air ni tak banyak signal yang kita boleh guna lah. So that's why kita akan guna wide control lah. Dia selalu dia ada wire ni. Okay, sebab yang selalu kita guna pun adalah ultrasonic lah, ataupun sonar dalam air. Kalau nak guna yang lain, GPS apa semua memang tak boleh lah. Kan, sensor lain memang susah. Okay. So kalau that's why kita akan guna ada wire remote untuk control dan send data daripada robot tu ke surface lah. Okay. So kalau kita tengok untuk medical, banyak juga untuk surgical punya robot. Okay, surgery untuk surgical robot ni. Dan kalau ada juga untuk bawa ataupun transfer biological punya sampel ataupun chemical samples. Okay, dan ada prosthetic limb lah. Kalau dalam medical ni, kita ada untuk kaki dan untuk tangan lah selalunya. Okay, so ini akan membantu yang person yang mungkin kaki ada terpaksa dipotong ke apa, untuk jalan semula lah dengan tangan lah. So basically kalau prosthetic limb ni memang banyak agak research dia yang dibuat, dan selalunya dia boleh connect dengan kita punya nerve lah. Dia boleh connect dengan kita punya nerve. Okay, untuk pergerakan ada juga. Okay, yang paling latest tu saya rasa mungkin nanorobots ni lah kot. Okay, nanorobots ni dia kecil je, mungkin kita boleh guna untuk dalam saluran darah lah selalunya. Tapi saya tak sure lagi ada ke tak dia punya application ni, tapi ini in the future lah saya rasa ni kebanyakan. Okay, nanorobots ni. So kalau kita tengok application dekat industri, banyaklah kalau application dekat industri ni. Salah satunya tadi yang welding tu welding. So basically kita akan guna dalam welding tu, saya pun ada satulah topik welding, tapi saya tak terang detail sebab dah ada Weldmart yang lagi banyak deal dengan welding ni, so dia orang pun dah terang banyak dah. Dan kalau dalam industri, so mostly robotik ni akan digunakan untuk material handling lah, mungkin load unload, okay. Untuk assembly, untuk inspection, welding and spray painting lah. Okay, ini antara yang saya listkan, mungkin ada lagi lah kategori dia. Tapi ini saya rasa yang lebih utama lah, banyakkan yang digunakan. Ada 5 ni. Okay. So kalau kita tengok material handling, selalunya robot akan digunakan sama ada untuk transfer part from one machine to one machine, or it needs to transfer parts from one place to another lah. Okay, dia sama ada dekat sebelah-sebelah aja, to one machine or to another place. Okay, another place ni mungkin kita perlu guna mobile robot lah. Okay, contoh daripada mungkin dia perlukan daripada dia punya gudang dia ke dia punya production line. Contoh dia perlukan raw material, so the mobile robot can take the part from gudang tu, and then it goes to the production line lah. Okay. So kalau yang from one machine to one machine ni, maybe you can use manipulator ataupun robotic arms je. Mungkin dia sebelah-sebelah je. So sebab reach untuk robotic arm ada yang panjang lah, so dia boleh angkat dan letak dekat tempat tu. Okay. So macam saya kata, kita boleh classify material handling ni into 2 types. Okay. First, machine loading and unloading, and also material and parts transfer lah. Okay. So material handling is a combination of art and science. So basically combination of moving, storing, protecting and controlling the material. So apa benefit kalau kita guna material handling robots ni? So basically as we know, it can reduce the cost of the production lah. Okay. And also it can maintain or improve the product quality, okay, reduce damage and provide for protection of the materials. The third one, it promotes safety and improve working condition. Okay, maybe kalau kita nak bawa barang-barang yang maybe chemical based, mungkin lebih senang kita gunakan robot lah instead of kita guna human. Mungkin takut dia leaking ke atau dia spill ke apa semua tu kan, takut kena bahagian-bahagian human lah. So kalau kita guna mobile robot ataupun robot ni, mungkin lebih selamat kepada human lah. Okay, and promote productivity and promote increase use of the facility, and you can control the inventory lah, inventory kita. So the material handling means providing the right amount, right material, right condition, right place, right position, right sequence, right time and method. So basically kalau kita cakap pasal material handling, selalunya kita perlukan semua ni lah. Okay, perlukan kalau dia nak angkat, the right amount of material tu lah, the condition dia dekat mana dia nak ni, semua perlu betul lah benda-benda tu. Okay. So kalau kita tengok machine loading and unloading, selalunya dalam machine loading unloading ni, robot akan digunakan untuk transfer dari satu part ke satu tempat yang lain lah. Okay, from one place to another lah. Okay. So the process can be mungkin dia ada loading saja, mungkin dia ada unloading saja, ataupun dia mungkin ada loading dan unloading dua-dua sekali lah. Okay, it depends on the process dekat production line tu. Okay. Okay. So dalam loading unloading ni saya tunjuk satu sampel je. So dalam sheet metal punya stamping press shop ni ada video dia ni, nanti saya tunjuk sekejap ya. kita boleh tengok lah robot tu dia load daripada satu tempat and after satu mesin lah, bukan tempat lah, satu mesin ni, daripada satu mesin bila dah siap kat mesin ni dia akan unload dan letak balik dekat next punya mesin. Okay. Dan nanti dia akan transfer sampai dia siap lah part tu. Okay. So kalau kita tengok sini very quick video je ni, kita boleh tengok lah. Basically dia guna robot arm lah ni manipulator. Okay. Okay, so baby dah sampai dekat yang akhir punya ni, dia akan transfer ke tempat lain lah, guna conveyor lah kat sini. Kalau ikut ni punya production ni, dia guna conveyor lah, dia transfer ke tempat lain. Okay, so kita boleh tengok lah dia very konsisten dia punya pergerakan tu. Dan macam rasa Encik Ellen tadi bagi tahu juga, kalau ada seorang yang tak datang bekerja ni, mungkin satu station tu akan stop lah kan. Kalau dia sakit ke apa kan, mungkin dia akan delay the production lah, kena ganti orang lain pula apa semua. Tapi robot boleh buat 24/7 lah dia punya Okay, so lagi kita boleh tengok juga ada untuk palletizing. Basically palletizing refers to operation that load and handling the objects such as carton lah or pallet lah, carton on the pallet or similar device. Okay, so kalau kita tengok dia load dan unload juga, tapi dia more kepada carton lah yang besar-besar ni sikit. Okay, so kita akan ada juga pick and place macam tadi kan. Tapi pick and place selalunya dia more kepada yang kecil sikit lah, benda yang nanti kita tengok lah pick and place. Tapi ni kalau untuk palletizing, nama pun pallet kan, palletizing ni dia more kepada yang besar-besar lah macam carton ni ataupun pallet lah. Kalau ada pallet kalau dia boleh angkat kan. Okay, so kalau ada palletizing, dia ada depalletizing lah. Kalau depalletizing dia unloading. Okay, cuma saya tak tulis ini je lah. Yang ni palletizing dia loading, depalletizing dia unloading lah, palletizing. Okay, so ini kita boleh tengok lah video. Dia angkat kotak-kotak. Okay, dia letak atas pallet lah. Okay. Okay, yang ni pick and place. So dia lebih kurang je macam palletizing punya robot. Cuma saya kategorikan dia pick and place dengan automation ni, dia lebih kecil lah robot dia ni. Okay, dia basically dia akan angkat, dia letak kat satu tempat lain lah. Dia tak letak atas pallet lah, dia mungkin letak atas conveyor ataupun letak dalam dia punya bekas ni lah, dia punya packaging dia. Okay, so ini video salah satu, ni dalam food industry lah, food industry. So kita boleh tengok lah every tu dia boleh angkat dan letak tempat yang betul lah. Okay, boleh kita tengok ni. Okay, so dia ada bentuk macam-macam tapi dia boleh pick bentuk yang betul dan letak di tempat betul. That's why tadi yang awal-awal tadi tu, kalau kita sembang pasal robot ni, handling ni dia perlu right amount, right material, right place apa semua tu kan, semua kena betul lah. Okay. And material and part transfer, usually kita akan guna mobile robot untuk transfer the parts, okay, from one place to another. Selalu yang kita guna dalam industri adalah AGV lah, kita panggil AGV, Automated Guided Vehicle. So Automated Guided Vehicle ni lah kita kalau tengok mobile robot, kita boleh jadi guided, boleh jadi autonomous. Autonomous maksud dia kita dia akan bergerak sendiri lah, kita akan set dia bergerak sendiri. Okay, dia boleh control itself lah. Okay, tapi kalau guided ni dia perlukan guide sikit lah. Mungkin selalu dalam AGV, dalam industri kita akan guna marker lah, line following marker ni, line following. Okay, line following punya robot. Okay, so the marker ni can be dekat floor dekat lantai tu, ataupun dia boleh guna juga vision or laser lah. Okay. So ini adalah contoh AGV yang diguna dekat industri. Saya tengok banyak juga industri sekarang dah guna dah AGV ni. Okay, so basically it consists of few sensors lah kat sini ya. So supaya dia boleh bergerak dan dia tak langgar orang lain lah. Okay, saya tengok saya pernah ke kilang di Sungai Petani. Dia orang pun dah guna AGV, so dia guna line following punya. So dia ada marker dekat lantai tu dan dia ada station dia. So every station dia akan stop dan nanti operator akan letak parts tu untuk transfer ke tempat lain lah. Dia mungkin ada proses lain dalam kilang tu, so dia guna AGV lah, dia ikut je. So bila dah siap, operator akan letak dalam dekat macam tempat, ada dia punya satu tempat untuk AGV ni, letak je part dalam tu, atas tu, lepas tu dia tray lah, kat tray tu, lepas tu dia akan bawa ke tempat lain AGV tu. So dia, saya duduk sembang-sembang juga, dia kata very effective lah benda ni. Dan okey lah, dia orang pun tak perlu nak berjalan banyak, dia cuma letak, operator lah tak perlu berjalan banyak, cuma letak atas AGV ni je untuk hantar tempat lain. Kalau tak nak kena tunggu orang lain ni kan, kena banyak manpower lah untuk hantar part pula. Okey, dalam assembly selalu kita nampak dalam automotive punya industri lah, sebab assembly kereta ni memang needs a few process lah kan. So basically kalau kita ada robot manipulator ni, mungkin kita boleh cepatkan proses assembly tu lah instead of kita guna human kan. So kalau dalam assembly ni boleh juga kita tengok ni adalah assembly kerusi juga. So dia tak perlu banyak lah, mungkin ada 2 je robot arm. Kalau kita tengok dekat industri kereta ni, automotive memang banyak lah. Okay. So kalau untuk assembly ni selalunya dia involve screwing of stud and screwing of thread sole, lepas tu insert shaft in the hole, lepas tu assemble of the small electric motors, plug, etc. lah. Okay, so selalu dibuatkan benda-benda kecil je macam nak screw, nak letak ni. So mungkin nak letak panel ni pun mungkin boleh guna juga panel pintu kereta tu kan. So ini kita boleh tengok video, ini mungkin dia tebuk lubang dan mungkin dia nak screw je lah kot. Okay. Okay, so kalau untuk inspection kita boleh tengok selalunya dia ada few types of mobile robots lah. So kalau ni tengok animal ni sama agak poster dynamic pun tadi saya tengok ada agak kat situ kata poster dynamic, tapi dia lebih kurang lah. Tapi animal ni dia company lain sikit. So kita boleh guna yang mobile robot macam ni, kita guna yang udara pun kita guna juga. So selalunya dia akan guna sensors lah untuk inspection, maybe dia ada vision. So dia banyak testing untuk non-NDT lah, non-static test. Kalau macam kalau kita tengok drone ni, dia more kepada nak inspect, tak nampak lah bawah dia tu kan, dia pipeline lah selalunya, pipeline. Okay, jadi kat udara lah. Okay, yang ni dekat laut macam tadi saya tunjuk mula-mula tu lah, cuma ni a few different robot lah. Okay, kalau kita tengok memang ada wire lah. Kalau dalam laut ni kita tak boleh elak guna kabel untuk send the data. So data kita tak boleh send through medium of water ni lah, dia memang susah. Okay, saya pun ada 10 minit lagi. So kalau untuk welding tadi pun dah banyak diterangkan oleh Walmart. Okay, cuma kalau welding kalau kita tengok memang ada banyak benefit lah. Okay, so selalunya kalau tengok welding kita ada 2 lah yang selalu digunakan, sama ada spot weld ataupun up weld lah. Okay, up weld. So spot weld banyak digunakan dekat automotive industri lah. Kalau kita tengok ni, semua ni robot arm ni adalah spot weld punya welding robot lah. Okay, so dia very specific dekat certain tempat dan certain setting lah selalunya. Okay, so involve setting patutnya yang betul lah dan also maintenance lah. Okay. Okay, lagi satu kita ada juga spray painting. So kalau tadi pun ada juga Walmart ada terang sikit, memang dulu saya kerja dekat kilang plastic injection molding tu, memang kita buat barang plastik dan also kita ada spray painting lah. So yang most common spray painting ni dia adalah bukan jenama lah, jenis dia adalah floor mounted. So maksud dia punya kaki tu dekat bawah. Okay, tapi ada satu yang saya buat dengan satu company dekat utara Malaysia ni. Okay, dia nak spray dia punya part tapi dia nak atas gantry, so dia terbalik. Okay, dia duduk atas gantry, dia hanging. So hanging tu sebab most of the spray painting tu dia design untuk floor mounted lah, tapi kalau hanging tu kita kena fikir setting yang lain sikit lah. Okay, sebab dia kena ada gantry apa semua tu, sebab dia nak kena bergerak kan. Dia satu station, bukan station lah, satu tempat ke satu tempat tu. Okay, dia ada macam dia punya section. Okay, so kita guna gantry. So very challenging jugalah yang tu. Tapi alhamdulillah kita dah berjaya untuk install lah benda tu, dan kita tengah buat dia punya commissioning lah, tengok macam mana dia okey ke tak. Sebab dia orang nak replace sprayer orang operator tu dengan yang dengan robot painting lah. Okay, sebab banyaklah dia punya isu dia tu. Isu satu quality, satu isu safety, health kan, dia punya kesihatan dia tu. So kalau kita tengok spray painting banyaklah advantage dia. Okay, so kalau kita tengok banyak yang spray part besar pun ada, part kecil pun ada. Okay, dan variation of material lah yang digunakan. Mungkin ini adalah metal lah kan. Metal mungkin ada juga untuk material lain lah. Okay, every spray tu dia akan guna dia punya nozzle yang berlainan lah. Okay, dan the very challenging part is how to keep dia punya line ni dia tak mengeras. Dia punya hose yang nak bawa paint tu ke dia punya nozzle tu. So very challenging lah. Tambah yang company tu memang dia punya curing time dia tu memang cepat. Dia cepat mengeras. Okay, ni video macam mana dia spray. Okay, so kita boleh tengok lah. Okay, sikit lagi saya akan terang sikit pasal mobile robot. So kalau tadi ada juga saya tengok apa tadi ada Sarah. Military drone ni consider as a robot or machine or craft. So kalau kalau ikut tarifan robot, kita boleh consider dia sebagai robot lah. Drone ni one of the robot lah. So kalau saya tunjuk sini mobile robot sikit. So robot capability to move around in the environment and not fixed to one physical location lah. So kalau kita tengok, kalau manipulator ataupun robot arm tu, dia akan fix pada satu location je lah. Okay, kalau mobile robot dia tak fix pada location. It can move around, okay, di mana-mana saja. Okay, so kalau dia ada banyak classification robot ni, ada yang classify dia by dia punya environment, ada classify by the move. Okay, so saya classify by environment lah. So basically mobile robot can classify into 3 lah. Kalau kita tengok yang major, kita ada ground, aerial and underwater. So kalau drone tu kita boleh cakap dia bawa aerial lah, udara. So kalau macam AGV tadi tu atau automated guided vehicle tu kita boleh kata kat ground lah. Okay. Dan kalau ada yang bawa dalam laut tu kita guna underwater lah. So kalau kita tengok pergerakan dia, kita boleh classify as walking, swimming. So selalu kita tengok legged lah. Legged, dia ada track, dia ada, kalau untuk ground lah, dia ada track, dia ada wheel. Okay. So kalau udara mungkin dia fly lah kan. Ya. Okay. So kenapa perlu ke satu tempat? So selalunya kita untuk transfer goods and material, to carry message, okay, dan lain-lain lah. Okay, so kalau kita tengok ni pun delivery pun sekarang dah guna drone dah. Okay, kalau tengok autonomous vehicle pun kita boleh consider sebagai mobile robot lah, sebab dia dah bergerak sendiri kan. So kita boleh consider lah, tapi selalu kita akan guna kategori yang lebih besar lah, dia guna autonomous vehicle lah, autonomous vehicle. Okay, so dan kalau kita tengok boleh juga guna dalam ni salah satu lah ni, drone ni dalam military tu. Okay, so kalau mobile robot ni how it works lah. So basically it needs sensors, motors, wave programming and the platform lah. Okay, platform dia ni maksud dia punya rangka apa semua ni lah. So basically sensors yang complicated lah, sensors yang complicated. So sensors kalau kita each situation or each condition it needs a different sensors lah. So kalau dalam bangunan mungkin guna sensors lain, mungkin kat luar boleh guna sensors lain. So selalu yang kita akan guna adalah ultrasonic, maybe untuk detection punya. So kita guna ultrasonic, LiDAR ataupun laser range finder lah. Okay. Okay. So kalau untuk pergerakan apa semua tu mungkin kita ada encoder, mungkin kita guna GPS kat luar. Mungkin kita boleh guna dia panggil SLAM lah, simultaneous localization and mapping lah. So dia akan guna LiDAR ni juga untuk mapping. Okay, ataupun ultrasonic. So future of robots. So yang saya nampak mungkin ke depan ni mungkin artificial intelligence punya area ni akan lebih meluas lah dengan adanya big data, machine learning, cloud semua tu. So kita boleh integrate dalam satu tempat je. Dan proses dalam satu tempat, mungkin boleh proses kat cloud juga dan tak perlu individual punya proses, tempat proses lah, contoh ni. So dia boleh semua, boleh decision boleh buat di cloud, dan cloud boleh connect dengan mana-mana punya sumber data je. Okay, tapi kena ingat juga kalau dia satu, kalau cloud ni mungkin dia ada privacy dan safety, dia cyber punya safety lah, perlu ada lah. Dia tak boleh lah sewenang-wenang dia boleh access semua data kan. So lagi satu saya nak tengok mungkin future robot ni mungkin human robot interaction lah. Okay, so contoh kalau macam diorang ni macam mana dia nak interact kan. So seperti yang Encik Alan ada, saya tak salah Alan ada bagi tahu juga, robot ni sebenarnya dia buta je. Kalau kita tengok dia tak tahu pun depan dia tu ada apa. So it depends on the sensors, it depends on the programming. So baru dia boleh tahu apa ada depan dia. Dan kalau dia nampak pun mungkin dia tak tahu tu benda apa, dan it needs decision making lah. Mungkin perlu daripada AI ni. So kadang-kadang dia nampak je itu 4 segi, tapi dia tak tahu 4 segi tu apa, kotak ke, kereta ke, apa-apa lah kan, telefon ke, dia tak tahu. Dia tahu 4 segi je. Dan kalau kita tengok mungkin evolution of robot, mungkin kita boleh tengok lah, mungkin daripada yang track ni mungkin dia akan jadi legged yang nampak seakan humanoid lah. Okay, dan dalam manipulator pun, robot arm pun mungkin advancement akan ada, tapi saya rasa dalam robot arm ataupun manipulator dia dah banyak lah, cuma dari segi application tu mungkin akan meluas lah. Okay. Dari segi anatomi ni anatomi of the robot tu. Okay. So kait-kait sikit dengan safety issue sebab kita dalam JKKP. So maybe dalam robotik punya safety issue ni mungkin kita boleh tengok human error. Human error ni bukan maksud dia human error waktu buat kerja tu, yang dekat stesen mungkin operator errors lah, operator tu yang operate robot tu. Okay, so kadang-kadang like I said, robot ni dia tak ada mata apa semua kan, mungkin dia ada a few sensors yang boleh detect untuk elak daripada obstacle, but then we need to be careful lah. Kadang-kadang dia berjalan je terus je, kalau terlanggar orang pun dia jalan juga sebab dia tak tahu pun dia langgar orang kan. So we need to be very careful, that's the safety lah. Okay, mungkin ada mechanical punya failure, mungkin ada electrical or control punya failure, so itu perlu tengok lah. That's why we need a regular ataupun perlu maintenance jugalah dalam robot ni. And maybe also because of the improper installation. Okay. Okay, kalau berminat dalam research, mungkin a few majors dalam yang robotics lah. So mungkin kita boleh tengok balik human robotic punya interface ataupun interaction, dan mobility and locomotion ni pergerakan dia, manipulation, sensors and perception and also programming. Okay, there's a few areas that still active doing research lah. Okay, so thank you. Terima kasih. Lebih sikit, 3 minit. Terus dah jawab tu ke?
Okay, terima kasih Doktor.
Ya.
Terima kasih Dr. Muhammad Sani. Ada apa-apa soalan daripada peserta? Mungkin kita ambil masa dalam 3-4 minit lah.
Okay.
Quick one lah.
Okay, saya tengok ni pada TS Abdul Razak Sabtu ni, pandangan saya, Dr. Sani, jalan 2030 pembuatan seluruh dunia akan berdepan kehilangan. Okay, tak semua, bagi saya tak semua industri kita boleh replace dengan robotics lah, tak semua industri. Tapi banyak juga isu-isu yang bila robot diganti tu memang akan ada kehilangan pekerjaan lah. Okay, tapi kalau industri, kalau dia nak buang semua pun tak boleh, sebab kadang-kadang macam sprayer painting robot kan, painting robot, even though kita boleh set dia, tapi we need a human touch lah untuk setting tu. So kalau dalam yang kilang yang saya buat tu, kemungkinan sprayer tu, human sprayer tu, operator tu dia mungkin tak akan dibuang, tapi dia akan operate mesin tu. Okay, dia akan operate dan untuk maintenance apa semua, sebab hanya setting dia orang tu yang boleh bagi robot tu jadi cantik lah, setting tu. Okay. Trend perkembangan kajian penggunaan robot dan AI. Saya rasa trend sekarang ni makin meningkat lah. Kalau kita tengok banyak especially kalau tengok animal tadi tu kan, yang macam apa booster dynamic punya robot tu yang ada macam kaki macam tu, banyak penggunaan robot digunakan untuk surveying, untuk inspection, okay, tempat-tempat yang dangerous lah. So trend dia saya rasa makin meningkat, dan AI juga meningkat sebab kita dah ada big data, kita ada machine learning, kita ada cloud. Tapi macam saya kata, kemungkinan ialah yang artificial punya intelligence ni kan, dia tak akan sehebat kita punya otak lah kot. Cuma it can make a few decision based on a certain situation. Saya rasa yang tu je lah perkembangan dia. Apakah ruang peluang yang boleh diambil oleh penyidik masa hadapan? Okey, kalau nak tengok penyelidik, macam area yang saya tunjuk tadi tu, a few areas that it can be explore more lah. Okey, so banyak sekarang ni ke arah human robot interface ataupun interaction lah. Okay. Dan also dia punya apa panggil artificial intelligence lah basically. Okay. Banyak yang ke arah situ sekarang ni. Okay, itu sebab sikit kot menjawab soalan kot.
Okey Doktor, terima kasih banyak
Ya.
atas perkongsian dan juga maklum balas tadi. Saya nampak teknologis Alex pun dah ready dah tu.
Okey.
Okey. Seterusnya bagi pembentangan ketiga, majlis menjemput wakil daripada Persatuan Teknologi Malaysia yang diwakili oleh teknologis Alex Pu Teng Su dan juga teknologis Louis Tay bagi menyampaikan pembentangan bertajuk IR4 in Construction Industry. Dipersilakan tuan.
Terima kasih moderator Encik Fadil. Selamat tengah hari kepada semua tuan-tuan dan puan-puan. Saya mengucapkan terima kasih juga kepada pengurusi program ini, TS Nasruddin dan juga JKKP lah. Biar saya on dulu share screen. I'm going to mix between Malay and English as well. Right? So I will cut short some of the notes over here because I think everyone will going to go for lunch. So my topic today is IR4 in construction industry, especially if let's say any example related to Malaysia, then I can give some of these examples, but not much because we are starting to get into that. So the outcome of these topics over here, I'm going to put it into 3 parts. Trends of IR 4.0. I'm looking at 12 tags over here. This part over here, the 12 tags, is actually coming from CIDB Malaysia. So there's one document on this. There's one document. Later I'm going to show you this. Then I'm going to identify possible application of IR 4.0 in Malaysia construction industry at the beginning stage because we are just going towards this IR 4.0. Then what are the challenges of IR 4.0 in Malaysia construction industry? Okay. Now you see that handphone in the beginning looked like this, very big, 1983s until now 2021. You look at the sizes and you look at the application over here. Why it moves so fast? One thing is in common. After year 2000, it moved very fast. You have color, you have a lot of these are so-called graphical because of one thing, internet. Right? So a lot of application we can use input into this device over here. But then when we come to construction, when you look at 50 years, handphone we are talking about 20 years, but then you look at bricks, 50 years, 1970, the brick looked like this. Until today, the brick still look like this. What are the technology available? In Malaysia, I'm saying that in Malaysia, we're still looking at that. But in other countries, when we talk about brick as a filling part of the construction component, they might not use this brick anymore. They might use other types of wall, drywall panelings. They're looking at their prefabrications of this concrete wall. They might have cast in situ wall, all kind of this. They improve. They follow the trend. They improve. But we are still stuck in this part. Now, but this thing of this going to change. Going to change because of internet, cloud computing, mobile phone, that which we can incorporate inside the industry and help the industry player to move faster. We're going to look into this part as well later. Another thing that we look at is actually artificial intelligence and machine learning. Some of this will involve robots to help us in the construction industry. I have some videos to show you about this, short videos. Then the part that the next part we are looking at to incorporate inside this construction industry will be virtual reality and augmented reality. Virtual reality is a part that I believe that ABM, Academic Binaan Malaysia, the one that in northern region, beside this UUM, they have a facilities of using virtual realities to train those crane operators, excavator operators. Instead of jump into the excavators that you're going to learn how to use it, they have a lab where those crane operators, when they want to learn it, they have a big screen, they have a chair, and then you have all the gadgets over there in front, the lever, all these things exactly same as a real excavators. So when you trying to move to the front, the chair is actually pushing you to the front. You can feel the real thing. And this is what virtual reality, you can use it. And as a matter of fact, this one, we have it in Malaysia. And some of the training center, they are using VR to do it. Just now I think we also get that the first Walmart over that, they also mentioned about VR in some of the training center. Augmented reality over here, I will see that in futures, especially in construction safety site, we might incorporate this into the industry. Other country like Singapore, they already have software, they have those sensors and scanning LiDAR devices. They can detect who did not wear safety helmet when they enter to the site. So immediately some alert can be issued, and then the site supervisor or even the security guards over there can alert the person, hey, you need to wear a safety gadget over here and there. And when you go to high places, working at high places, so these high places over here, we might have sensor as well to alert siren, okay, giving a warning sign that, oh, you are very much close to the edge of the buildings where it's still under construction. The barrier, although it's there, but then you have to be careful. So these are all augmented reality. It can really help out. Now the next part is autonomous equipment. Just now, Dr. Sani also mentioned about robots. This part over here is real. Honda division is actually having this ATV, all-terrain vehicles, where they mounted all the sensors and they can detect the contour, pre-calculated, with the load that they carry over here, whether it is good for this automated vehicle to go down or up to move into a terrain. With this, you do not need to risk human life driving this and figure out whether I can move the vehicle up and down or not. But this is all automated, because with all these technologies over here, it can be safe for a person to work in the site and to carry out the site according to the schedule as well. Now, all these development over here encourage Malaysia to go to this construction 4.0. If you track back 2016, CIDB actually put up a roadmap on this construction transformation plan. They're trying to incorporate this into the industry. I think now 2021, they come up with this document. So this document specified a lot of things that what contractors should do, and the industry should do, consultants should do, the developer should do. So these are all the strategy put inside. So if let's say you like to have a look of this, it's a public document. You can go to CIDB website. You can download this. It's about 400 over meg, 90 over pages, very concise. And I'm not going to discuss in detail what's that. It might take hours just to go through that. But overall, this document over here tell you about some of the history of this, and then what are the proposed things that you should do. Now, Malaysia, when we talk about construction industry, in the early stage, we are looking at manual drawing. If let's say you want to look at construction 4.0, in terms of quantum, what is 4.0, what is 1.0? 1.0 part is where we are still using technical drawing, technical pen. I believe that those who have the age of 40 years and above, when you learn in your university, you're learning technical drawing. So after that, in between, maybe squeeze in AutoCAD. AutoCAD, this is in 2.0. You're using software to draw a 2D. Then after some time, maybe in the late 2010 or even 2008, it come up in BIM and 3D drawing over here, 3.0. And now we are talking about 4.0, 2021 onwards. So you look at this 2D, 3D, now is ND. ND is that the dimension over here, not looking at the X, Y, and Z form. It can come up to be 4D, 5D, 6D, 7D, or even 8Ds right now. The 8Ds that Singapore doing right now is actually more to occupational safety and health, where they're using BIM and others. These are IoTs to incorporate into the technologies. Example, one of the things that I can see what they're doing right now is this. They put their buildings into BIM models, and they put it into the clouds, and then they have software in their handphone over that. When, let's say, emergency, you have a fire, So the person who installed the application, basically they have the BIM models of the buildings, and they know where is the fire, and they know where is the shortest exit. So they can, the software itself can guide them, to escape which part they're going to move on. So these are the futures that we should look into. Now, inside this this are strategic plan 2021-2025. CIDB for the first time introduced this, this 12 patch. If you look at others industrial 4.0, for the electronics part or others industry part, they don't call it patch, they call it pillar. Some call it 9 pillar, after that 10 pillar, 11 pillar. But for our construction industry, we have 12 patch. 12 patch consists of BIM, prefab, modular construction, autonomous construction, augmented reality and visualization, 3D printing, additive manufacturing, artificial intelligence, blockchain, big data, advanced building material, cloud and real-time collaboration, 3D scanning and photogrammetry, Internet of Things. And these are all 12 patch that proposed by CIDB. Now, with all these patch over here, which patch should be used in the beginning stage? Because contractors over here, developers over might think, I want to go for Industry 4.0, industrial construction, Industrial 4.0. So which one should I kickstart? Which government agency, institution, NGO that can assist in providing information on this? Are we ready for 4.0? These are the questions that everyone should ask. This is new to us. So I would say that let's look at this. This is artificial intelligence. Let's play some video over here. I disable the voice, no points. We just want to look at this. You can see a robot. It's been programmed. We have saw all these kind of sensors. This is a drywall. It can pick up the things, rotate from Japan, and he can detect the start horizontal member. Put out a nail. You can see precisely, and of course you will say that the robot is bulky, this and that, but through time, it can be make it much more humanoid, look like humanoid, and it might be much more intelligent. But this is real. This is not a movie. This is real. Already have. Just that Malaysia might take some time to go towards that. But since there's somebody doing it, then the progression of this might go more and more. Of course, all these things come from military. When military invented all those droid robots, then they take part of the technologies and incorporate into others. So construction is the one of it benefit from that. Next part, you look at this. This part is more to autonomous construction as well. Look at the way that they lay brick. No human. This is a machine, and this is real. This is not a prototype. This is use ready. So you have a robotic arm, the sensor, and then the mortar itself is pre-mixed. Brick itself is using conveyor belt will pull it out, and they can lay according to the position that they want. You can look at the mortar, spacing between mortar is exactly the specification stated. It's so straight. So compared to conventional workers, when they lay, of course, you might be very fast, but then is it straight? You might have problem in qualities in the futures. So of course, I do not need to go through videos. It's running out of time. Next, you look at this plastering. This is also one of the technology already been used in China, India, and a few others. But I think China use a lot of this. So we still rely on foreign workers or even some locals to do plastering. But with this machine over here, you can see that how fast it can do. Fast is one thing. The second thing we are looking at is actually the quality of the plaster. You can see it's very consistent. The flatness, I think, no doubt, not many human capable of doing like this, and it is fast. It is fast. Of course, it might not be 100% automated. I can see humans still pouring in the plaster into this bucket, right? And the adjustment of this rail over here still need to have human to pull it from one side to one side. But through times, when if let's say we input in more and more ideas, and engineers around the world should be able to figure out way how to fully automate this. But of course, the point is not fully automated. The point is, if let's say we can have partial automated, it can help out and ease up a lot of current issue that our construction industry facing right now. IR 4.0 is one of the way that can go lah, right? So I'm going to complete the video. Let's go to the next part. Next part, we get steel to autonomous construction. You look at this. This is a bar bending machine, right? In our job site, we might have workers, foreign workers, pulling out all the bar, which is 9 meter length, 12 meter length, or even 6 meter length, and then trying to bend it and cut it. Right? It will take time. Right? But we have machine like this, right? Automated. Right? When engineers design the buildings using a software, and they come up with these bar schedules in their software, the data from the software itself actually can transfer to a machine code, the machine language. And this machine language over here automatically can cut to the size that you want, whatever. Right? You can see this is still 2D cutting, no issue. Right? But 2D bend and cut, okay. But then sometimes in 3D form, like a link of a chair, it's not as simple as a human can do it. But this machine, you can do it. Right? Expand surface, blah, blah, blah. You can see that all this part over here, not every time it can be done by human. But for the machine, it can be easily carried out. The one that I'm going to show you on this point over here, if let's say in construction industry, we are talking about standard length, right? 6 meter, 9 meter, 12 meters, then there will be a lot of wastages. But for this, you look at this, you do not need to have a standard length. You can have a row, right? We have a row. When you have a row over here, you can stop any time that you want. But then if let's say it is in construction, you need to plan ahead. Hey, you're going to purchase 6 meters, 9 meters, or even 12 meters. Why we need to do that? Because we're trying to cut down the wastages. Because after you cut to the end over here, the last part you're going to throw away. But with this, you have a row. The last part is the last part of the row. You can cut down the wastages. So this will be the way to go. Right? So next part, prefab modular construction. This for Malaysia, we are looking at IBS. We call this one IBS. So this IBS over here, of course, picking up very, very fast. But I would say that we need some of government support, right, in certain way to push the developers to go into this modular type. Next will be this additive manufacturing. It is like coming up of this joint. Let's say we have a joint over here. Arup is one of it that use this. Right? Conventionally, we have this, but very difficult to fabricate even to this and this. So today technology, we're talking about 3D printing. So 3D printing of metal over here can come up with this. Why we need to have this? This part over here can have a very high efficiency in the joint part. But of course, if you do this, it might not be efficient enough. And the construction of this might not simple as easy enough to do it, because you want to cast something like this. The mold itself is quite tough. But then for 3D printing, then this problem solved. Right? Now, this is a video of 3D printing of a house. Right? I look at the way that I'm running out of time. Right? But again, I'm showing you a wall only. So we'll fast forward a bit. Right? How they print the house, printing the house. It's about 10,000 US dollar. Right? I think the print house is in front. Right? They print the house like that. Right? The machine is print. Right? It can print in 24 hours. Right? Next part. Now I'm showing you augmented reality. This part over here, many countries already adopted it and use it. This is one company, SRI, using it. I fast forward a bit to let you see what actually happening inside. Front part over here, I think is redundant. It's just want to show you that, let's say you are the supervisor on site and you have to carry up your drawing papers, your plan to go to the site and do the checking. But with these technologies over here, you do not need to do so. You're having your BIM models in the control station, and then once you go inside, you will have this so-called specialized spectacles over here to tell you what is inside there, what have you built. And when you reach certain part over here, then you can see, oh, you want to check this. You have to check whether the door opening is according to your design dimension or not. You can just use your finger and click. Oh, then they tell you, oh, this part over here is 31.75. It's incorrect. And then what your actually these sensors over here is sensing your finger. When your finger move, it will send something to a screen, the part in front. Then you can put up a note, you can put up an audio voice, and your control station actually is going to record this and tell me that what happened on the site. Right? Okay, I'm not going to go through also. Okay. So the next part will be this augmented realities on drone, using drone. Drone itself, it can help out construction in many ways. Right? One of the ways actually to check the progress of the construction, to check some visual part, whether let's say when you want to hoist up some materials from bottom part to go to the other side, because you only need bird eye view to see, aerial view to see whether it's workable or not. So if you spend human to climb up scaffolding to the position and look, it might be time consuming and also dangerous. But then with drones, it will be very fast. I can tell you that recently I have conducted one of my projects in Penang itself. That is for 20 over acres and it is hillside. And if let's say I really go down going to this MCO here, also quite tough. So I just engage a company that having this drone over here. Then they go to the site and then on the top they go around about 30 minutes. Of course, the drone can only take about I think 10 minutes or 20 minutes, depends on the battery. And then they have to do a field trip. They recorded this and then just put up into the clouds, and then I just play back and see what's happening over there. So it's quite effective. And the best part for this drone over here, if let's say I engage professional surveyors and also the consultant or me myself go to the site over there, I might wasted a lot of times. And I might also have some risk if let's say hill slope over there. I'm not talking about the slope of 25 or 30, 40. It might go until 75 degrees. So you need to have some special kind of person to guide you to climb on those type of slope. But then with this drone over here, it solved my problem. Really solved my problem. So let's go to the next part. We have big data, BIM, augmented reality. All this joined together can help out in this building information modeling. Concept of this path over here. So I believe those who in construction industry were going to be very familiar with these pictures, these pictures, starting from this conceptual design, detailed design analysis, documentation, fabrication, construction of 4D and 5D, construction logistic, operation, maintenance, renovation until the end. Even if let's say after 100 years you decided that you want to demolish and rebuild, you still have the data in hand, the model in hand, how are you going to demolish it? You can plan ahead of this. So which government agency, institution, NGO that can assist in providing information of Industrial Revolution 4.0? CIDB is one of the key person. A lot of document actually started by CIDB. But beside that, you have some minor information that you can get it from this Ministry of International Trade and Industry, MITI. There are some appendix over there can help you on this part. And beside that, government body, MBOT, PEM or LAM, they have some information on this as well. Then lastly, you can refer to NGO. I'm from Technological Association Malaysia, and also can refer to IM, PEM or MBM. So I have some paper cuttings. It say that CIDB also say that 2018, CIDB e-construct service Sdn Bhd, see back over here. They are talking about this so-called Industrial 4.0 and then Fourth Industrial Revolution 4.0, and that is the roadmap at that time. 2021 now we are talking about the plan already. They start to kick off already, and they are asking some of the NGO to help them out, PAM and Institution of Malaysia to help out. But today's PAM is actually can assist everyone as well. Now, are we ready for Industrial 4.0? This 50% will come from me myself. It's not, there's no survey, but then I'm in the industry for more than 25 years. I will say that 50%, the way I look at this. How do I come up from this 50%? Because we are technically ready. Technically, I would say ready. Because for academic part here, if you check around local universities, many of them actually already have this software. They learn all this software, BIM, AR, VR, they have it already. And then the CIDB also regulate a lot of personnel in this part. The technology of just the 12 tech over there, I think maybe 80% easily available. It's only the terms of money, like whether you're willing to venture or not. So university and professional body are ready to work hand in hand to fine-tune the transformation of this IR 4.0. Now, what are the challenges that our industry face? We have three parties over here: developer, contractors, and consultant. You look at this, the way I put it is actually mindset. Everyone don't want to start because they are thinking about, if let's say I venture into that, will I get back my return? I venture into that, I have to buy new technologies, I have to invest in that. Can I get back the money in time? That is their mindset. Yes, I will say that if you follow the strategy well, the plan well, you should be, not only that you get back your investment, you actually can get some profit from that as well. Okay, but of course, this part over here is very much depend on what? Depend on this part. You have to, based on your ability. You don't, if let's say your company payout is about let's say 1 million, you don't go beyond your abilities lah. You venture into something that is just nice for you. Once you venture into that tech, you have 12 tech, right? You choose any 12 tech, then you have to recruit those person specialized in that field to assist you. You don't be kedekut lah, jangan kata kedekut lah. You buy, after that you expecting your old staff to help you to do that, and then you send your staff to do the training. It might not work because of the mindset. Because when you don't think like that, your staff don't think it will work, and it will never work. You have to recruit those in this field, expert in this field, the one that can use the tech to assist you, then it will work. So set logical target based on company resources strength. You don't look at, let's say the company ABC in US can do it, company ABC in Singapore can do it, Malaysia boleh, Malaysia also can do it. Yeah, we can, but then we have to set a logical planning. We have to start from small, gain your experience. Once you have this stage, you go to the next stage and the next stage. So almost complete, almost complete. I would say that most of the time, you can easily convince the boss, but the boss might having a long time, a difficult time to convince his team, project manager, site supervisor, and site admin, because they are old timer. They might not know what is the benefit of that. They might also even worried, as just now one of the question raised. Will this technology replace human? So I would say that no, it's not. You still need a human to operate this and that. So I would say that to kickstart of this, you can set up a new division, small division just on that. The old stuff still remain, and then you put up a new division. This new division where you recruit a new guy. So you let two teams work together, means this team over here can see, can observe what the new teams do, and they learn from that. Eventually, you will look at it, this part over here actually can assist my job, help out my job. It can secure my safety. It can make my job much more perfect according to the specification given by the consultant. So eventually, I think this will be balanced out, and then everyone will happy with the new tech over here. So last part over here, government legislations and tax incentive, all submission to authorities should be mandatory using BIM. This is much more ideal, but I hope that one day we can do that. But of course, CIDB saying that they want to do it, but I'm not sure that every local authority agree with that, because UBBL doesn't have that. So hopefully some of the laws also adapt to this BIM, then we can do that. R&D, if let's say those companies that venture in that, they must have R&D. So I'm proposing that if let's say there's an R&D tax reduction to spend on this 4.0, then it will be benefit the company as well, because you can have tax deduction. Accelerated tax reparation on computers, automated machinery that meets IR 4.0. If let's say you venture with it, you should be able to get this depreciation tax as well. Now, before I conclude conclusion, all key role players in construction industry must adopt a new mindset. Mindset is important and refresh culture within their company. Start small with achievable batch to hit logical target within company resources ability. Then lastly, precision management strategies will reduce cost and fuel usage that eventually reduce carbon footprint for greener futures. So thank you very much. Let's look at any question. Okay, no question. Good. So I pass it to Luis. I pass it to TS Luis.
Hi, sure. Hi. Good afternoon. It's already past 12:30. It's going well. Let me share my slides. Alex, can my screen be seen? Alex?
Yes.
Okay. So my topic and my talk is actually a continuation. Alex and me, we are both from the building and construction work group of TAM, Technological Association Malaysia. So I will continue what he talked about. I will be more focusing on the issue about the best practices and digital transformation. If you look at what Alex talked about, the 12 technology, and it starts with BIM, and then it comes through all the technology the CIDB was saying, and then at the side by side, at the another end of it is IoT. In fact, that is quite a nice graphic in a way, because it actually tells the whole story. Every single technology there has to do with digital technology. It's a digital transformation we're doing, and it must start with creating the information. BIM is about creating the digital twin. Finally, when you have all the digital twin and everything connected, it is what we call Internet of Things, IoT. So I'll illustrate this, and I make it quite interesting and simple. First of all, allow me to illustrate. I'm coming from industry. So my industry, my company, we look at adopting technology, both construction and digital technology, to help the sector, the construction sector. This is one of the latest. We just finished it last time only. I'm just showing you. This is the prefabricated with some pre-finished construction method. It is for urgent need of the current industry. A lot of the hoo-ha over the workers' accommodation and the spread of pandemic. So we actually designed this whole thing using BIM, and we actually fabricate this thing using BIM direct output. And in our factory, we actually use a robotic system. So this, but first thing is you must be able to design it in BIM, and then the BIM will trigger, and BIM will trigger this so this is just a short video. And this perhaps will give some information to some of our friends here who attended because this is actually a very quick method, and put up accommodation for 200 workers in a week. Everything is just ready, prepared, and plugged in, and installed. The toilet is actually PVU. In order to put a pandemic in the industry, both CIDB and JKKP, they are encouraging safe work bubble. So if the workers and the site are all contained in one location, it's much easier to contain the pandemic. So this is actually one of the solutions to help to erect this quickly. This thing can be erected and can be dismantled and reused. So that's a beautiful part about prefabrication technology. So you may see that these are designed using lightweight steel structure and prefab sandwich panel, things like that. It may not be anything aggressive in terms of the material. But what we use is beam technology to actually detail everything and output the shop drawing into our automatic production line, especially in the cutting and building of holes. And then go into, of course, there are still some manual fabrication things. And then finally, we put the whole thing together. And these are modular. You can have any size, any length, as long as we design and then it's using the same component. So this is also prepack technology at the same time. Okay, I think let's move on. Okay, so I'm talking about how to add professional service with IDD, integrated digital delivery. That's what we are talking about. When we talk about IR 4.0, we are talking about digital delivery. And when Alex just now talked about the the gap between the IR 3 in Industrial Revolution 3 and 4 is actually not automation, not robotic. That is already a technology available. But what is different is not only creating the multiple dimensions of this information, is also creating a seamless linkage so that for example, a lot of technology you see now, you actually need to rework your input into that technology, that method, whatever robotic cutting or welding. What we are talking about here is to achieve IR 4.0 is that you need to have the linkage directly. When you create that design, it is already ready to link to production. Now, just now, Alex showed you about the rebars, the auto production rebars. That technology is many years. It's already there. But what is making that technology more productive today is the seamless linkage. When we create beam, we create the model. When the CNS engineer design the rebar, that design is ready to plug into the production. That is what we mean by IR 4.0. It's that linkage, the automation of the processes. And we all know that the construction industry is the least productive industry in Malaysia and in the world. And currently, the problem is because of the lack of adoption in investment in innovation and technology. So the current status of the industry is a lot of wastage, a lot of rework. What do you mean by rework? For example, the rebar thing that Alex showed you is the best example of rework. When the designer create the rebars, it is not ready to produce. So when the QS pick up the quantity from the design, with so tedious taking off method, that is a really one-time rework. Because when you create a rebars, by right, the quantity is already there. So when the QS put it in the BQ, the contractor win the award and the contractor win the contract, they are given construction drawing. Then in order to fabricate the rebar, they have to come up with shop drawing again. So 2 times rework, that is a lot of wastage. That is the wastage in processes that we do not realize. And it is actually unproductive. So these are the 10 root causes that actually haunted the industry, and that's why we are very low in productivity. So these are some theory, fundamental theory, so we can jump on it. That last year, McKinsey come out with this report. This is a very expensive report. They have done a lot of research. I think they spent at least 20 million euro to come out that. They're looking at what is the next norms, next 9 shifts. Okay, what are the new norm coming into the construction industry? The blue color 1 to 9. It's talking about product-based approach, which means prefabrication. You got to do IBS, industrial building system. So you build your car in the factory, you build your house in the factory. Same method. You need to talk about specialization. You need to control your supply chain consolidation and blah blah blah, all these things. And these are driven by what? These are driven by disruptions. Okay. And one of the main disruptions, which I boxed up in red color, is actually digitalization. The one previous report McKinsey released a few years before that, they don't use the word digitalization, they use the word digitization. Now the world now realize what is digital transformation is not only to adopt digital work content, to create digital work content, it's actually to create digital work processes. So the whole concept of digitalization is in both things. the content of your work and the process of your work has to be automated. And this is the current value chains in the construction industry. It's very fragmented, and then from one process to another process, and then you have a large middleman here, which is the distribution, rental thing. But the future of this is going to be totally digitally integrated. So the process of back will actually, before you design your building, the product actually existed in a certain way. Either in a digital way or in the physical way. The production line is customized to do the product. So you got to design based on the product. So this whole thing are the trend. They're talking about 9 trend here. So these are available for reading. So let's move on. Now, ultimately, when we talk about finally, when we manage to adopt BIM in construction industry, and what are we bringing? What are we producing at the end of the day? When we manage to integrate BIM into the multiple value chain, we are actually completing this whole thing about IoT, Internet of Things, and this will take shape. This will take many years to complete. At one end, you need all these advanced network like 5G, all these. But on the other end, what about those things that you want to connect together? Now, today you can connect your aircon with IoT, you can connect your CCTV, your IoT, and all this connection is because you have put in actuator sensor into the device and link it digitally, and you empower it with some AI, cloud computing, and all these things to make it smart. So you are creating a digital twin. All these devices that you put it into your device is a digital twin. Now, what about the building itself? What about the building? The building itself, the condominium or the apartment you stay in, has to have a digital twin. They got to be able to connect. Alex give you a very good example of that. For example, you have a condo and you have all these fire detector sensors, smoke sensor. You can actually detect where the fire break out, and then then what it means is you will connect to the digital twin of the condo and map out the escape path for every single individual. It means every single individual is linked to this digital twin of the condo by their handphone, their smart device. And then the system will compute which is the safer path for each of them. Every single one, customized path for them to escape. Not only that, your entire CCTV system of your condo is also linked up. It is also linked up with IoT and applied with what we call it AI. It's called the vision intelligence. So it will actually look at all the exit, all the emergency exit door, which one is blocked. So in the process of computing this safe escape path, you link everything up. You link the CCTV, you link the fire sensor, you link this, you link that, and you may actually link to the control of some important doors that was normally locked, and then it released the lock. So and also even the lift, So these are the what we are talking about. Creating this digital linkage is what we need to achieve the IR 4.0. So digital twin is actually an enabler. So it's actually creating something that actually looks like the real thing, behave like the real thing, and connect it to the IoT, and it is used to make decisions. So we are creating BIM for that purpose. Okay, so this is the benefit and the journey when you go BIM. So I make it more interesting by introducing something. This is how we create this. This project, the project is really big, but they need a digital twin. They don't even have an accurate view. So this technology was deployed. First, we use a LiDAR scanning technology to scan the building. However, then we have to convert it into a BIM model. So in fact, to make this whole thing happen, we actually make at least use 3 to 4 software. So this is after the scan, 360-degree photographic representation of the built asset can be produced, and then you start take the point cloud And this is already the rendered beam model view. And when the model is created, any kind of drawing can be produced for subsequent process and all the purpose. So what I'm trying to say is, yeah, this is just one example. The right way for this to happen, ideally in the future, is this project should have started with BIM. So BIM can be used to automate a lot of construction process. And at the end of the project, you send in some more advanced device to scan and compare. Have you constructed accordingly? However, they actually specified BIM initiative in this. But however, because the project was very complicated and very huge and dragged over too long a time, so along the path, they eventually give up the BIM effort. So but they realize that even they complete the project, they still want to have the BIM for future maintenance purpose. So BIM journey is actually about not only about creating the building information models. It's actually building information management. You look at it from the data point of view. So it is actually creating a collaboration that is transparent and creating digitalization of processes. So it's actually, this is a very famous theory. This is actually a McLamy curve. It's actually a move from the dark blue curve to the pink color curve. The benefit is all there. Is you actually have more details produced before you implement the job. Ideally, you want to do that. But technically, technology-wise, we can't do that in the old days. Today, because imagine when you produce 2,000-3,000 pieces of drawing, who is having that capability to put everything together and coordinate before you put to construction? So our construction process in the old days is very much a try and error. It's just like asking you pergi pentas pergi nyanyi satu concert baru tapi tanpa kasih you chance untuk buat any rehearsal. That is construction up to today. But under BIM, you do virtual construction. So before you go to the pentas, you sudah buat 2-3 kali full dress rehearsal. Dah tahu lagu itu, dah tahu itu music, dah tahu itu mana lighting itu akan pergi lah. You know, so you dah rehearse before you put on it. So this is what we mean by shifting the curve, the paradigm shift. This is necessary because why are construction contributing to 50% of the accidents in the in occupation and health aspect, safety and health aspect, and that is because it is a very unplanned and it's lack of coordinations and very hazardous, kind of process. So then we are talking about BIM adoption towards integrated digital delivery. This is what we call I-BIM, integrated BIM. This is the world perspective. So the world now is in the turning of between level 2 and level 3. So it is not matured yet. It is still developing. But we need to know, if you want to be advanced, you better know what is coming. So this is why we need to know where we need to position ourselves. So if you want to adopt BIM, you're adopting BIM not for the level 2 reason. It's so that the whole nation, whole country can go to level 3. So the right strategy in adoption is very important, like what Alex just now said. So again, BIM adoption is actually towards from the very fragmented kind of efforts. In the old days, kita ada contract. Saya dengan you ada contract. So our communication follow the contract. But that is still the truth. But in future, now, when you do BIM, there is also another relationship. You could exchange information and collaborate processes openly based on the data in the center. So this is what we call digital transformation. And we are looking at the entire build asset life cycle rather than just project life cycle. Jadi apa-apa yang kita buat itu, the model, it's not only for construction only, it's going to be for entire life cycle. That's why I always, when I talk to Tuan Nasruddin, we are already planning the fact that BIM is very important in OSHIM implementation, because OSHIM, you need to identify all the safety and health risks. But when you implement OSHIM, you want to create a safety and health file. Who is going to benefit from the safety and health file? It is the people who occupy and maintain the building. So using BIM to create the safety and health file is a very important tool, and it's going to link every information, link all processes together. So this is when we achieve BIM and deliver IDD, integrated digital delivery, from the conventional practice in construction, architecture, engineering, service. Kita design, we look at compliance and serviceability, but now you actually look at constructability and maintainability. You look at you are not only creation focused, you are also sustainability focused. We are not looking only at the work content. We need to work at the work process itself. And we are not only going to be a link because of value chains, because of contractors. We're going to link because of digital. And then on top of the quality and safety management system, there's got to be a digital information management system. This is the new thing. Value keep changing, job keep changing. Why kita cakap kita punya job akan ubah in the new time? Because the value kena tambah. The human cannot just do so little. A lot of things is automated lah. So I want to end with last two videos. This is to show there's a very complicated job, okay? And when you put all the M&E together, you just simply don't know how to coordinate. So BIM is used. But when you use BIM to design all this detail, what is the next thing? How you make sure that we can actually go to IR 4.0? Can you produce robotic production? I'm showing you that. Okay, so first video first. These are the drawings. Okay. When you lay everything together, you can't see anything. Semua hitam aja, So then you actually build it. Okay. What we do is we virtually construct it. So what you need to do is you actually need to construct it as if you are really physically constructing. And you can even go to all the bolt and nut and all the hanger. But you said this one is not there yet. But however, you're supposed to go to all that detail. This one is with all the detail, position, everything, elbow, everything other position. Whether the human boleh masuk tak boleh masuk pun all consider. And from there, you produce the model, the constructible thing, and we see how complicated it is. And even with BIM, it looks so complicated. If it's without BIM, how do you expect a contractor actually coordinate that? I can tell you, I'm from the construction industry. No human can efficiently or effectively coordinate that. So what they do is the contractor will say that, okay, you itu pipe air punya orang ke, you jalan dulu, then kita ikut belakang. So try and error. That is really what happening in the industry. So, but now this is the means. You actually can put in as much as detail you want. And then what do you use all this detail for? Not only for coordination. The fabrication of ducting can actually output to CNC machine, even to fabricate all the units. All this, the quantity are all there, the length are all there. So this can be automated. It can produce a shop drawing. Not only that, the next video show you that, okay, this is something new. Okay, this is what we currently we are working on. We are investing in this thing. If you have all the position done, you can you actually use it to let me see this. Yeah. Okay, so lastly, this equipment it's just a robot. To those who are specialized in robot, what is so special about this is actually that the robot is linked to all the position that you already pre-designed in BIM, and it actually find those positions by itself and link to the GPS, link to whatever surveying method, and they find the position and they drill the point for you. So what is actually significant in this, behind this adoption of robot to find and drill the hole for you, is actually the linkage back to your design. When you design it, you already can make automation in production eventually. And it's actually the linkage. It actually linked to the geospace coordinate, whatever, and then they can find a position. So it is linkage, and linkage. This is what the Industry 4.0 need to. Okay, so I'm this is the same video. Okay, so just bear in mind when we talk about digital transformation, when we talk about BIM adoption towards IDD, it's actually we are talking about the change, not only buying the technology. You got to change in data, how you create your data. You got to change your process. You got to change your people capacity. So this is what really the digital transformation need to be. So these are some basic theory. Just now, Alex was talking about how you adopt. This is very important. Last slide, okay? How you adopt technology. When you adopt technology yang you boleh mampu, that's what you say. It's true. But when you adopt technology, you mampu is good thing. But when you should do it, you should do it when your business is still slightly better than normal productivity. Everything is talking about productivity. It means your output and input is balanced. You got your input can make enough output for you to have profit. So that is the point where you start invest technology. Kalau satu hari in the business the black card starting point is already below the blue line. I can tell you there'll be a lot of pressure to switch to technology to do the transformation, to do any change, because the business is already in the way, in loss. And how do you convince the bank to loan you money to invest in the new technology? So, but however, when you adopt the technology, the change, that doesn't mean you can improve your productivity immediately. There is going to be a curve that you need to climb through, and then you come up again, because you need to relearn, regenerate the new gap, to close the gap. So then ultimately you are going to much higher technology. So not only the money you invest in, like what Alex say, is the investment. It is this value ini cerun ini that you're going to sustain because during this time your workers, your team will be very frustrated because they can't produce as efficient as before. It's because they need to switch technology. Okay, so I think I cover everything I intended to. No doubt there's many more things, but it's okay. We have plenty of chance to catch up, because JKKP, CIDB, and TAM, and also a few industry stakeholders, we are organizing a major talk, which is a hub day talk, a heavy event coming end of the month. And the keynote will be on the what Alex talked about, the BIM submission. It's actually called National BIM E-Submission. It is coming. So we have actually CIDB talking about it, and then we have multiple aspect of it. And also we are inviting JKKP to talk about their 2025 blueprint. Okay, so that's all we can cover today.
Chris,
and
there's one question. I think whether you want to answer the question.
Yes,
you
sir.
check the chat box over there.
Oh. Okay, let's see how we can answer the question. Bagaimana sambutan penggunaan teknologi BIM di industri pembinaan, apa yang patut dilakukan nowadays? It's actually receiving much better than compared to several years before. Now, give you an example. I've been in this BIM business. I mean, most of you may know that Plytech is actually quite a pioneer player in this BIM business. So this is our 5th year. So no doubt, the first 4 years, a lot of investment, belum tengok lagi keuntungan sikit pun. Tapi these years, despite all the pandemic situation, the BIM business is picking up. The BIM business volume is equal to double of last year. It means a lot of projects already switched to BIM. Especially a lot of international projects yang kita buat untuk industri ni. Like currently there's this, I think there's this job, I think Robert Bosch Texas Instrument, a few more. They already, when the job landed in Malaysia, back in their HQ is already designed in BIM. If you cannot talk this language, you cannot talk on this language with them on BIM, you just can't do the job. So just bear in mind one thing, the BIM will be the only language you are going to use. You're going to need that. So our sambutan may be still slow. If you compare to e-commerce, okay, what happened is last 2 years e-commerce grow like our expectation, of course, because of the pandemic. But this BIM is still on a very healthy growing path. I would say that is definitely going to be there one. It's just like so I see a lot of senior people here. Just like when we entered the market 25, 30 years ago, when people shift from manual drafting to AutoCAD, okay, that is digitization, okay. And I remember when I entered as a young engineer, a lot of very senior designer coordinator who doesn't want to switch to AutoCAD, and they think that their art in drafting is fantastic. Eventually, they have to change their job role. They can't be on the design table anymore. They become a project coordinator, things like that. So it's about technology that you need to. It's going to be a new language you're going to pick up, and if you are in the constructions. Some of the I remember some of the thing the Alex showed in the video. Almost everything is already there, even including the 3D printing, putting the mortar. I've seen it with my eyes. When we did a research 3 years ago in China, I went to 2 factories. It's there already one. It's just that because it doesn't print the rebar together, so it's limited to a smaller, not high rise and things like that, Okay, so yeah.
I might add a bit on this. I look at the way I look at this. Actually, the BIM for the past 2 to 3 years is picking up quite fast, But before that, I think when CIP started to promote BIM in 2016, it's a bit slow in the beginning. But in order to as what TS Azruddin question, how to bagaimana menggalakkan penggunaan teknologi? I think the way that we can do is actually we might look at the model of Singapore. They put it into their act, in their akta. So right now we have some problem over here because every municipal have their own rules ruling here and that. UBBL is another issue that they are dealing with. So if let's say they want to do a submission, whether in BIM or not, a lot of people reluctant here and that. So if let's say we put it into the act, and not only one, a few others, because there might be loopholes saying that, hey, UBBL claim didn't have to do this and that, and then another authority saying that not this act and what. So I think all the authority body have to sit down saying that we have to standardize that we have to go for e-submission. Then that is the only way to go. If only one body that want to do it, and then there is some loophole in other act, then developer or even the consultant might looking at the loophole and enter without the e-submission of e-BIM. That is my personal opinion. I think I hand back to the organizer. Right? Thank you.
Okay, terima kasih banyak teknologis Alex, Pu dan Wiste. Ada lagi?
Yeah, you continue. I just give me a chance to show one slide, which is a very valuable slide. We actually. Yeah, just 1 minute only. I just want to show this slide. Okay, this one actually we spend a lot of time, and also and the entire industry with the MPC. This is we actually have come up with the roadmap on how you adopt BIM. Okay, there are 3 stages and multiple phases. So it is actually from startup to grow mature. Even we ourselves, we are between the number 4 and number 5 at the moment. A lot of trouble with the industry is they think that the misconception is that they think that it's about buying a software. It's not about buying a software itself. It's actually about, like I said, it's actually a digital transformation. So they need to look at 4 things. Software is a technology only. What about how you're going to store your data? How you're going to share your data? What is the protocol of doing that? And then you need to talk about the people and the processes. So you got to look at all these things before you can actually talk about BIM adoption. When you want to adopt BIM, think of it as BIM, Building Information Management. Don't just do Building Information Modeling, because if model cannot be blended into processes and cannot be managed, and then there is no value we can create it. You just create a model, and sometimes the model is just like a toy for fun only, So okay, this is I'm sure we will have more sessions, and especially the end of this month, there will be a good session coming, and let's follow up and chat to each other lah. Thank you. Okay.
Okey, terima kasih sekali lagi. Peringatan mesra kepada peserta-peserta yang masih belum mengisi kehadiran dan juga penilaian pohon isi. Link ada dalam komen tu. Nanti kita akan hantar e-cert digital, CJ digital lah nanti ya. Okey, dengan itu kita telah selesai ketiga-tiga pembentangan bagi program webinar Teknologi Revolusi Industri 4.0 dan Teknologi Robotik kita pada hari ini. So, saya rasa banyaklah teknologi-teknologi baru yang telah dikongsikan, mungkin yang banyak yang menarik dan boleh membantu kita lah dalam tugasan kita setiap hari. Dengan itu majlis mengucapkan ribuan terima kasih kepada semua pihak yang terlibat pada hari ini. Tuan Teknologis Nazruddin Ma'ali, ahli-ahli panel kita daripada Wellmat, Unimap dan Persatuan Teknologi Malaysia PAM, ahli-ahli Jawatankuasa Strategi 6, OSMP 2025 dan tuan-tuan hadirin sekalian. Terima kasih banyak. Semoga kita semua mendapat manfaat lah daripada program kita pada hari ini. Saya mohon maaf lah kalau ada apa-apa kekurangan. Dan akhir kata dari saya, #kita jaga kita dan stay safe everyone. Okay, sekian, terima kasih dan jumpa lagi.
Yes. Okay, thank you.
Terima kasih.